I was gonna be so on time today too, and then I tried to call into the dentist's office to make an appointment because I haven't been to the dentist in an embarrassingly long time. But they kept me on hold for like 20 minutes when they said the wait time would be like 5 minutes. So I'm kind of like backed up. Phineas and Ferb doing a math stream? Okay. Oh, we do have one. We have to draw from Anders as well. Is the music playing? Yeah. It's just really quiet right now. We're live on YouTube. Okay. Thanks for the work, Zach. Hope your stuff goes well today. Music is on? Okay. Excited to see this when you return. Good, good. All right, let me get my usual PDFs open as well, just in the background for abstract algebra and for E&M. Okay. So we might do that later. We might also do some coding. But let's do these drawings first. Because I don't think, yeah, there's nothing in my Discord asking for like math help right now, so. Okay, so I guess we'll work on Zach's redeem first, but yesterday, Anders redeemed for the future for today, draw 2 different cats using only math symbols. So we have that redeemed to work on too. I think we'll do Zach's first though. Oh, I didn't close my windows. You guys are gonna hear the cars going by. Let me actually close my windows. Ah. Okay, there's one window. There's another window. And of course, you know, here in my luxurious mansion, it takes a long time to get all my windows closed. You know, wash my hands too. Hope you guys enjoy this water ASMR. I don't know if you can hear me drying my hands. I wonder how sensitive the mic is. Okay. Anyway. Okay. Phineas and Ferb doing a math stream. Well, so Ferb doesn't talk, right? I feel like it'd be funny to have him being the one explaining the math, but doing it completely silently. So I'm thinking we're gonna have maybe like a whiteboard with Ferb, and then maybe like the computer with Phineas like running interference with the chat and stuff. I don't know how you would do a collab math stream like this. Let's just start with that much at least. So there's our whiteboard. Probably, I'm starting off a little big. It's going to take up a lot of real estate on the whiteboard. Let's hope we don't get like a partial fractions problem to do over here or something. Probably draw Ferb like right there. And we're going to put some math on that whiteboard, but now Ferb is like 90% head, if I remember right. Like his head is super tall, so in the shape of an F. I don't know what kind of like clothes they wear though. If they have some kind of, oops, his arm. He's gonna have a really stretchy arm, I guess. Okay, and then, God, how do you draw Ferb's head? It's such a, like, an anomaly. It's literally, wait, that's not how an F looks. It's almost like a shark, right? Isn't, oh my God. Yeah, because I need to look up how Ferb looks, I guess. It's been a little too long. Hey, how's it going? It's good to see you. Phineas and Ferb. Oh wait, Ferb doesn't have like that kind of like forehead, I guess. Huh. Okay. Good to see you too. I'm a. I currently have to do some art because I have a channel points redeemed to make so people can make me draw stuff, and I got one to make Phineas and Ferb doing a math stream. So that's the outline of my Ferb so far. Ferb has purple pants and a white shirt. Okay. Well, we don't have purple, but we can at least do blue. He has green hair, which we can do. Is work still super busy for you, Tay? Okay. He looks kind of like a punk so far with his jeans and stuff, but we'll roll with it. He's got big ol' eyes. That come out of the side of his head, to be fair. Oh god. He's a little cross-eyed, but don't make fun of him, please, you know. Been way busy. I've been focused on that. Had a surgery. Oh no! All is well though? Alright, well, I'm glad to hear that. Surgery is never fun. Okay, there's a hand. Then we'll have another hand right there, but it has to be holding a marker. Herb's gonna hold a green marker. Why not? It looks a little like a chisel, but you know, who cares? D by dx. What should I say? I feel like a lot of people have asked about the question like arc sin x. That'll be what Ferb is doing. He doesn't need feet, I guess. That'd be good. Then we do need to draw Phineas as well. Dude, these art readings are getting a little elaborate. It started off like draw a cat, and now I have to draw like a whole scene. Rough couple weeks of recovery. Aw, dang. It was worth it. I found a bunch of staples in your abdomen. Oh. Holy crap. Yeah, glad that you're recovering well. And hey, Obi. I was wondering why staples were in your abdomen. I was like, did you swallow staples? But no, they were left there by when you had your appendix removed. Yeah, that's pretty terrible to have to deal with. So I'm glad that you're hopefully going to come out better for it. All right. Then we need Phineas. I should have. I mean, I used orange for his hands, but I didn't use orange for his face. That's going to kind of bug me. I didn't give him a mouth either. Sure. I don't know how I feel about this like spray tan that's happening, but you know, we'll go with it. You don't need staples for funsies? Well, you know, I don't want to assume things stay, but yeah. Green hair. Ferb has green hair. I'm looking at an image, yeah. Okay, so I'm gonna I guess draw Ferb at the computer. Can be like Twitch chat there, and then dude, Actually, to be fair, I think the first time I added this art redeem, I think someone redeemed like the Mona Lisa. So this might still be simpler than that one, at least. Okay, so what does Ferb wear? An orange striped shirt. Oh yeah, the Oompa Loompa song. I forgot about that, Tay. Oh my god. I miss those hard lock streams. Wait, did something get posted in my Discord? I see a little icon. Yeah, they were. Oh, okay, looks like Boat is tackling this geometry problem that I had no idea what to do with. Which I'm glad that someone is, because I sure know I don't know how to do it. Okay, how do we draw Ferb sitting down in this chair? So we just start by... just start drawing, right? Got some slender legs. Dude, he's way too far away from the computer. He's gonna have some really stretchy arms now. Oh, I gave him a little bit of a beer belly here too, but you know, maybe Phineas has really let himself go. Who knows? Yep. That's how arms are like. Okay, so Phineas's head, it's basically a triangle with an ear. You gotta go back to work. All right, well, thanks for lurking. You have a good night too. Okay, so literally his head, like the back of his head is just an extension of his neck. It's got some orange hair up there. Dude. The shape of his head looks so much more natural when you see it in the show, but this is a little freaky the way that I'm drawing it. It's got the tiniest little patch of orange hair up here. God, dude, this is bad. Okay, that might have to do, because I have to get to Andrews's redeem, and I have to probably do something that isn't drawing. Oh, Banana Butler, hey. Or Banana Buter. Sorry. I need help on this one. Let A0, A7 be a regular heptagon. But 1 over A0, A1. Or sorry, prove that 1 over A0, A1 equals 1 over A0, A2. Are those the angles? Or are those the side lengths? Those are probably side lengths. Wait, if it's regular, how can that possibly? Ooh, maybe. Oh. Lines from A0 to A1. All right. This is Hey, hello Jenny. It's going pretty good. How about you? All right, let's tackle this one. So heptagon. Wait, there might be one too many points. Like, so heptagon is 7 sides, right? But A0 to A7 is 8 vertices. Let me make sure I'm not misremembering what heptagon is. Heptagon. Yeah, 7 straight sides and angles. 1, 2, 3, 4, 5, 6, 7. A6, yeah. No worries. I mean, I would have figured it out anyway, so make sure that I wasn't crazy. Actually, wait, how does heptagon look? I should actually images, heptagon. Okay. I'm not sure exactly how we're gonna do this, but let's take a look at what's actually happening with this heptagon. So that's 3 sides. Oh God. Wait. Every side should come in pairs now. I drew that one base. Dude, this is... I drew that base way too wide. Okay, 1, 2, 3, 4, 5, 6, 7. Okay, A0, A1, A2, A3, A4, A5, A6. So we want to show one over A0, A1 equals 1 over... Yeah, Fedlox, it should be A6. I'll edit the problem that I posted, I guess. There we go. It doesn't really matter anyway because oh, no worries, $10. It doesn't matter because we're only talking about the first what, like 4 of these points, but yeah. A0 was at A2, and then A0, A3. Sure, copy things down, right? Okay. Doing well, just about to finish chapter 1 of your linear algebra book, I assume? Or maybe your book is also linear. Imagine a non-linear book where, like, you go to page 1 and then you have to go to page... or like, what would like a non-linear book be? Like you have to do some like exponential progression through the pages. Like you start at page 1, you go to page 2, you go to page 4, you go to page 8, you go to page 16. Okay, sorry, I'm just being weird, but we're interested in A0, A2, and A0, A3. Really? This is going to be true? That 1 over that like segment is equal to 1 over that segment plus 1 over that. I mean, maybe that's true since it's 1 over. I guess I could see how that's potentially true. We have an isosceles triangle here with A0, A1, A2. How that helps yet, I'm not really sure yet. Linear algebra, yeah. This is like the quadrilateral of A0 through A3. It's a trapezoid, if I remember my quadrilaterals right. It's basically the Pizza Hut logo, right? what's throwing me off is like how do we even begin with getting 1 over a0 a1 in like a natural way? Or do we just force it and see what happens? Or do we try and like rewrite this in some other form that's easier for us to understand how we get here? Like, what if I multiplied everything through by the denominators? What would we get? A0, A2, A0, A3 equals... Oh, that's gonna be... I don't have enough room where I started writing. So if I took that equation, just rewrote it by multiplying each side through by all the denominators, we would get A0, A2 times A0, A3 equals A0, A1. I should really name these sides, but... meh. A0, A2. Okay. I don't know if that helps, but that's at least a thing we could try to equivalently improve. That seems like we have a bit more to chew on. The Honey Cat. How about going to the complex unit circle and bringing all the tools of complex algebra? I have no idea how you would accomplish that. It could be. I have never solved a geometry problem with complex variables before, to be honest. So I don't know how you like. I don't know any like the tricks there. So like, what is A0, A2 times A0, A3? A0, A2, A0, A3. It's the area of the rectangle formed with those two segments. Like, could we make this some equivalent problem where A0, A3 is the longer side? I should actually exaggerate the differences here. I don't know if that's important, but let's A0, A1 is the shortest side. Oh, shoot. I'm trying to draw things kind of to scale. This rectangle should be thinner, but the same height. I don't know if this rectangle thing is going to be helpful in the first place. I'm just kind of curious to see if it can go anywhere. So, I don't know, that's my crappily to scale drawing here. This problem's equivalent to saying that an equals e to the 2I pi over n. For someone who's not comfortable with this technique, I have no idea what you're saying, Honey Cat. I'm sorry. I have no idea like how we use this. Like, I know a little bit about complex variables, but you'd have to really hold my hand to at least get me to understand that. Although, I guess Banana Buter, do you use complex variables at all for geometry problems? Because this line of thinking might not even help the person asking the question. Oh, wait, welcome in, Cat. I guess I'll say. You kind of do? You know, it's an interesting approach. I'm just like trying to, I don't want to like go off the rails with saying something that the person hasn't used. Like extremely hard stuff, but you can get around. Okay. So I guess I'd be more interested in a non-complex variables technique if it could be helped, but if Banana does know some complex variables, then if you feel like trying to hold my hand through this solution, then I'm happy to like see it, but it's going to be a lot of like trouble, so I wouldn't blame you if you didn't. Can we express A0, A2 in terms of A0, A1? Because we had that isosceles triangle? Here, like, we express the base of this. If it's a regular heptagon, all the angles n minus 2 times 180, is that the formula? Is that 5 times 180? Formula for angle sum of regular polygon. N minus 2 times 180. Dude, I called it. So what's 5 times 180? 900. Okay, so the angles in a regular heptagon add to 900. Which means each individual angle, 900 divided by 7. Does that actually... I guess it doesn't have to go unevenly, does it? It certainly doesn't go unevenly. It's... They're about 128.6 degrees, we can call it, I guess. $128.6. So if that's 128.6 at the apex, these two angles are 180 minus 128.6, which is 51.4 divided by 2. Oh my god, I'm not going to do that in my head. 51.4 divided by 2. 25.7. So if we drew that height, we know that half of A0, A2 is equal to, for, we would want cosine for this, right? Cosine of 25.7 degrees is equal to adjacent over hypotenuse. Adjacent is 1/2 A0, A2 over A0, A1. So we can write A0, A2 in terms of A0, A1. We rearrange this equation. 2 A0, A1 times cosine 25.7 degrees is A0, A2. I don't know if that helps us, but that's kind of neat, I guess. A0, A3 is kind of a tricky one. I don't see exactly what we do with that. What is that, Bode? Where does that polynomial come from? Complex numbers? Oh, okay. Yeah, that, I mean, I I definitely don't see how that helps, but it may help. I just don't know that technique. Would this even help us, like, do anything? Is there some kind of formula, like, I'm trying to think about, like, maybe we can get some kind of similar presentation for A0, A3. We can maybe do something with that. Like, plug it into this side of the formula and come out to get that. Or equivalently up here, I guess. That'd be, I guess that's how you would prove this. Because, like, we could take this chunk here, plug it into A0, A2 there. If we can get some kind of similar chunk only in terms of A0, A1 for A0, A3, we could hope that this boils, that whatever this math is, comes out to be 1 over A0, A1. But how do you express A0, A3 in terms of A1? A0, A1. We don't have a nice isosceles triangle. We do have a trapezoid. I guess let's draw it and start thinking. I can flip my marker all day, but that won't help. A0, A1, A2, A3. So we could form two right triangles and a rectangle. That appeals to us. We know these two angles are. We can assume these two angles down here should be equal, and so we can figure out those two angles. So I can see how we can get these two bits here. How do we get the middle bit? It's equal to A1, A2, which is equal to A0, A1. Oh, maybe this, if this works, I'm gonna be a happy boy, I guess. 25.7 degrees. So, sorry. 128.6. And so if we can, the angles of a quadrilateral add to 360. So let's do 128.6 plus 128.6, subtract out 360, divide by 2. Cyclotomic polynomials. Oh, never heard that term. Hey, Shep. Add the katza to the math. I do have a redeem from Anders to draw cats with math symbols that I'll do the next time there's some downtime. 360 minus 2 times 128.6 divided by 2. 51.4. That's gonna... There's probably a reason why it's similar to the isosceles triangle. I don't know it, but... Wait, 51.4? Okay. Okay, so just call this point down here B. A0, A3 is equal to a0, I guess twice a0 b plus a1 a2, which we're going to say is the same as a0 a1 because it's a regular heptagon. So a0b is that side there. So if we do a little bit of trig, we can say it's that cosine at 51.4 degrees is a0b over a0 a1. So we can say it's a0 a1 cosine 51.4 degrees is a0b. And I'm multiplying it by 2 to capture this part of the segment over here as well. Okay, well, we have everything in terms of a0, a1. So let's plug it in up here and hope and like cross our fingers. So if this doesn't work, I don't have any other ideas. So you checked yours and it's correct. You have a solution. You already worn out, Shep? Oh, I'm sorry. Yeah, if you're able to type up some kind of like hint for banana, it might help them out. I don't know if they're gonna be able, if they're gonna be comfortable with that solution technique, but that's why I'm trying to do it like this more like, I guess, classical way, would you call it? Or just using kind of like normal geometry things. Classical is probably a bad word to use here, but. All right, so let's try plugging into the formula and see where the chips fall. So a0, a2 is this. We can relate these cosines with a half-angle formula. God, what is this, dude? This is gonna be a mess of algebra. I kind of want to plug it into Wolfram Alpha. Because that's gonna be a lot of algebra to work through, but just to realize that I maybe made a mistake somewhere. So let's actually start off with going to Wolfram here. Instead of a0, a1, I'm going to write x. 1 over 2x cosine 25.7. It's actually the thing you sent. Oh, did you send something? Oh, it's the thing you sent before in chat. Okay. Fair enough. Hey, Viv. I got to redeem to draw Phineas and Ferb doing a math stream. So that's what's on the left side of the board there. I got another redeem that I got to do once there's some downtime. 1 over 2x cosine 51.4 plus x, right? Please be 1 over x. Please be 1 over x. 1.13482 over x? That might be a rounding issue. It's a little bit big. Man, it shouldn't be. No, it shouldn't be a rounding issue. Use degrees. Maybe that's it. Oh, dude, this is right. Okay, so there's a slight like rounding issue here. But I think the equation that I set up is right because we're getting 1 over x, which is what I would want to get. It's going to be a pain to clean up this algebra. But Banana, before I venture further into the problem, do you understand what I've done so far at least? Because I wasn't doing a very good job of explaining it. It makes sense? Okay, cool. So yeah, really what I've done is I've broken it down into an isosceles triangle and a trapezoid, and I analyzed those to get, with the goal of getting A0, A2, and A0, A3 in terms of A0, A1. Let me look up our half angle or double angle formula. So cosine of 2 theta, 2 cosine squared. I forgot we get a square in there. All right, see you, ship. I won't. Sleep well. Okay, we can forget about the rectangles in this interpretation here. So when trying to simplify this, do we want to get a common denominator first? I feel like we wouldn't. I think we want to deal with these 2 cosine angles being different and apply a double angle formula to maybe this one so we can reduce the angle by half. So let's do that. And I'm gonna, instead of A0, A1, I'm just gonna write X here because it's gonna be a lot less writing. 2x cosine 25.7. 1 over 2x. So cosine of 2 theta. Oh, yes, okay, I have to draw some cats once I have some downtime. 2 cosine squared 25.7 plus 1 minus 1. Plus x. Okay. This is kind of terrible looking. We can do this. Let's simplify that denominator. I'm gonna come like I guess over here. I don't even know. So let's multiply that 2x in here and combine the minus 2x plus x. So that'll be 4x cosine squared. Minus 2x plus x is minus x. Okay. This is nearly the square of that, except it's not. Okay, so if I get a common denominator for each of these fractions, well, do we even want a common denominator? I guess we do. Yeah. If I get a common denominator, I just need to multiply this entire thing. No, I don't. Do I? I do need to multiply it. I mean, can I be sneaky and find something to multiply just by this so I can keep that the same and not multiply it by anything? I can multiply it by, no, I don't think I can. Okay, we'll do it the old-fashioned way. I'm gonna multiply this by that entire thing in the denominator over itself. Get 4x cosine squared 25.7 degrees minus x plus this is going to get multiplied by that entire thing over itself. (5.7 degrees) over these two things multiplied. Okay. Uh, like, this simplifies, man. I'm not seeing how. Everything should go away here except the x, except one of the x's in the denominator. Oh, really, Bode? That's interesting. Hey, Omar. I have no idea what you're saying. Please speak English. Well, we can cancel a 2x. We got that going for us. No, we can cancel just an x. That minus x spoils the 2, unfortunately. Is this going to factor into something that cancels? That'd be nice. Okay, I'm going to cancel an x from everything, I guess. Like these 3 x's over that 1 x. Maybe we can factor the cosines in the numerator. Okay, so I guess, Banana, I should say, I feel like the point of the problem we've already done. I feel like the point of the problem was this part over here. And what I'm doing now is kind of the painful algebra part to actually follow through on this work. But I feel like the real kind of point of the problem was solving this part over here. This part is just going to be kind of tedious. Unfortunately. Let's multiply out the bottom, I guess. So we're going to have 2 cosine cubed 25.7 degrees. Wait, sorry, that's 8x cosine cubed. Because the 2 is still there, and one of those x's is still there. And then 2 cosine 25.7 times minus x. Minus 2x squared cosine 25.7 degrees. Okay. This is still terrible. Hey, Omar, you like math? Well, awesome. Glad to have you here. See, I feel like I've already made a mistake here because we have one too many x's in the denominator. Why did this become x? No, we don't. I just don't know. I just kept forgetting that I canceled an x. So ideally, we can factor this x out of the denominator, and everything else cancels miraculously to become 1. I'm not quite sure of how. I mean, the numerator actually does factor. So numerator we can factor to be 2 cosine squared. It does factor, right? I hope it does. I'll need to check what I'm about to write. Minus 1, and that has to be times that plus 1. I don't think this factors. If we had 4x squared, it's hard to see with cosines, plus 2x minus 1, does that factor? We could do a 2x and a 2x, or 4x. It's not going to be 4 and 1x. It has to be this one if it does work. It has to be minus 1 and a plus 1. I guess it doesn't necessarily matter where. So you get negative 2x. No, that's a difference of 2 squares. That isn't, no. I don't think that factors. Let me just make sure I'm not making some dumb mistake. I'll plug it into Wolfram quick. The little polynomial or little quadratic that I made. No, it doesn't. I mean, it factors irrationally. So, like, if it doesn't... It doesn't factor, then what? Did I mess up a sign or something? Like, maybe we should plug like this step in and make sure it still comes out to be okay. Hey, Lead Ninja, welcome in. Double check my calculation. I could. Hey, Maz, welcome in. I think it should be right though, Finlux. So when I plugged in like the answer that I got here, wait, why is that plus x? I magically made that into minus x. Okay. Well, there's your problem. That's why it didn't factor. So I assume that it was right because when I plugged this thing, I get back out 1 over a0, a1. So I'm happy to double check it, but I assume that if it got the right answer, that it's okay. Something looked wrong. Oh, sorry. It's like, I think this part is right. I just forgot that's plus and not minus, apparently. That should factor now, I think. It'd be... No. No! Ah, that has to be 4. Dang. On the graphical resolution of any equation? Are you talking about if you have like, I'm a little bit of a different problem, but if you, are you asking about like if you have y is less than or equal to 2x plus 1, how you graph that inequality? I could try and talk about that, after I hopefully get through this problem at least. Oh wait, it became a minus x because of that. Oh shoot, no. It is supposed to be minus x. I forgot, it became a minus x because of the double angle. So I'm still going to plug in the thing that I have here and see if it still gets the right answer, or if I've already made a mistake. You said yeah, it's that, Ninja? Okay. See, I'm sorry, there's going to be a little bit of a wait as I try to figure out this problem, but you'll be up next. I feel like I'm close to solving this problem. So I don't want to drop it. Unless I really get stuck. Cosine 25.7 cubed. Get that x out of the cube. Minus 2x cosine 25.7. Why didn't you give me an option to convert this into degrees? Well, this is the same answer that we got in radians. So it should be okay still. I'm having trouble actually getting this simplification though. How does 8x cubed minus 2x factor? If they just happen to be the same thing, I guess we can... I don't think they will be the same thing. 0 plus and minus a half. The thing is, for 4x squared plus 2x minus 1, we get irrational roots. Which they should... what? How do these cosines possibly go away? Really, $10? I guess I don't know if Banana knows that, I guess. Like, Banana, have you heard the term cyclotomic polynomial? Because I'd never heard of those before. If someone can walk me through it, then we can take a look, but... if Banana hasn't learned it, then I don't know what to, Banana hasn't heard of that. Roots of unity. For me, that's still not helping because I don't know anything about that stuff. Like, if someone can write an explanation to give me something to Google, I'll take a better look at it. But like, all right, $10 is cooking. Hey, Oler, what kind of stuff? I can teach you how to struggle with geometry problems. I'm really good at that. So some of all these roots has to add up to 0 by symmetry. I'm still not sure how this applies to the geometry problem. But I guess I'm following so far. I can accept what you're saying is true anyway. Oh, is 2 pi over 7 the same as 25.7? I should have... oh, right, 360 degrees over... yeah, okay, duh. I should have put 2 and 2 pi together sooner. I wish Wolfram Alpha gave me a step-by-step here. So know what to do with that though? Okay. It's fair. Up trig. Trig can be fun. Right now it's not being my friend. Since I'm home with a 10-sided shape. Okay. I'm about to. What I have on the board, I think, is a right answer. I just can't figure out how you actually simplify it to get across the finish line. If you're allowed to plug stuff into a calculator, it should come out to be 1. Like all that cosine stuff, it should just come out to be 1, and you end up with just an x on the bottom. But I can't figure out how to do that algebraically. Thanks so much. I'm probably gonna mispronounce it, but Bas van der Eek. I appreciate the kind words. So yeah, Banana, I'm sorry, but I might have to call the problem here. If you want to take a screenshot of what I have so far, at least, because I know that it should be right. If you're allowed to just use a calculator, that would be really nice. Trying to do this algebraically is not pretty. Yeah. Thank you for the question, Banana. Well, Ninja, if you're still here, I'm happy to talk about your question. But let me know if you are still here. Because I still want to keep other people waiting for too long. That's something that I would be able to figure this out sooner, I guess. Maybe? I feel like I've gotten kind of similar thing, but in terms of like, you know, my weird like cosine stuff. Not seeing anything from the Ninja, unfortunately. I'll type in chat at Ninja in case they Okay. Hey, Menendez. Menendez. How's it going? It's good to hear. I'm kind of bummed that my solution... I can't figure out the algebraic way to get my solution. But I guess, I feel like calculator should be good enough too, right? This is a problem that was from Banana Buter in chat. Geometry problem, pretty tough one though. I think I have the right work so far. I just can't figure out the algebra to really prove it, but I do technically have the answer. It's just, if I'm not allowed to use a calculator, I can't actually prove it. I'm about to move on to a different one though. Or move on to do something else right now. You're not from USA? Okay, no worries. Seems like the ninja may have dipped. It's a geometry problem involving a 7-sided polygon called a heptagon. I'm about to erase it now, but yeah. I don't know. It's probably a more advanced geometry problem. It feels like, so not in early on grade. You have to prove that 1 over this side is equal to 1 over that length plus 1 over that length, like this formula here. Which my work up until this point, I'm pretty sure is right, but it's just actually getting to the end goal is kind of hard. I do have one more drawing that I have to do. You don't think your idea works? Oh, dang, okay. Bad sign, no chalk present. To me, it's a good sign that no chalk is present. Interesting problem, though. Okay. Do you do trig and graphs? Yeah, usually. If you have a problem, feel free to put it there in chat. Hey, Yanis. It was a pretty tough geometry problem from someone over in the YouTube chat. I technically got the right answer, but it was... I couldn't actually do it algebraically all the way to the end. Didn't pan out, but I think it's on the right track. Oh, okay, fair. All right, so I do have another drawing to do here. Anders wants 2 different cats using only math symbols to be drawn. Yeah, that's a super interesting way to solve geometry problems. I just like am completely unfamiliar with it, that's why I didn't want to go too far down the path. It'd be cool to like learn it one day maybe, but doesn't necessarily help the person who's asking the question. So 2 different cats using only math symbols. I'm gonna put we have a whole list of math symbols here, just for that I can use as my menu. Do you know some basics about metric spaces? So maybe you can help me with my homework. I don't know the first thing about metric spaces other than they deal with measures. Or metrics, you might even say. There might be someone in chat who knows about metric spaces, but I think Zach mentioned taking a measure theory class recently. I wouldn't know where to start with that though, unfortunately. Yeah, over over in the economics world, they stomp on the symbols we use for math, as far as I can tell. Pi is not an irrational number there. Pi is something else entirely. Measures and metrics are different things? Really? I thought... Okay, well, I see. So clearly you don't want me attempting to help you out with your homework then, because I don't know what a metric space is. I thought they were the same thing. It's really called a metric space. What else would it be? Like a metric... I think like the metric system, like, measures things. Yeah. All right, I think I have part of my idea if I can draw two cats using math symbols. Let's just start drawing. We'll do a blue cat. So I was thinking, I mean, like, you can do like a curly D for the, like, partial derivative for like the body and like part of the head. Right? I mean, even a 6, I guess. But, and then this is, the ears can be like a logical and. The tail can be an integral. I guess a double integral. We can actually... That's kind of a crappy... Okay. Measure spaces have measures, metric spaces have metrics. What's the difference? Is it like, I think of the word metric, that means a measure, like outside of the context of math. I guess that's where my, that's why I made that assumption. That's evidently wrong. A measure is like the 8 of something? I don't know what that part means, I guess. I set x with a function d that acts like a distance function. Hey, Ishan Niyogi? Triangle ABC has a right angle at C. The internal bisectors of BAC and ABC meet BC and CA at point P and Q respectively. The points M and N are the feet of the perpendiculars. There's a lot going on with this triangle. All right, I'll try to draw this thing out, Ishan. It sounds... I'm not sure exactly what's happening with this problem, but let's see if we can wrap our heads around it. So the perpendicular, or sorry, Q do derivative. Oh, sorry, Menendez, I didn't even see that. Yeah, that'll be a quick question, so let me do that first before I look at Ishan's. Because if we solve the derivative of sine of 5x, we can do that basically 2 steps here. It's a chain rule problem. So if we want to find f prime x, when I do chain rule, I normally, because we have sine as a function and 5x is a function, so I normally work from the inside functions, I work from the outside functions and go in. So I'm going to start by deriving sine, pretending like we just have an x there. So sine derives to cosine, and whatever was inside the sine, we put inside the cosine, so 5x. So we've derived the outside, now let's derive the inside. The derivative of 5x is just 5. So we get cosine of 5x times 5, and I'll rearrange it to look nicer, which is 5 cosine 5x. So that's the derivative of sine of 5x. Okay, let me know if that makes sense. I'm gonna go back to drawing Ishan's problem. So angle BAC, the internal bisector of BAC meets BC at point P, okay? I should really draw I drew an isosceles right triangle, and that's gonna mislead me. Let's draw one leg obviously longer than the other, just so we don't accidentally make an assumption here. I forgot what we called that point. P. And then this angle bisector is at point Q. The points M and N are the feet of the perpendiculars from P and Q to AB. So M is the perpendicular with P, I'll say. N is that point. Find angle MCN. MCN. Oh, wow. This is going to be a tough one. What is Comcast? Like the internet service provider? Oh yeah, I should display this problem. There we go. Oops, I should fix that part. Show so that CM and Q is concyclic. I don't know that term. Maybe it helps. This question is trivial and left an exercise for the streamer. Hey, Badwi. This is one of those tough geometry problems. 2 of them in one day. They lie on a common circle. It is a quadrilateral inscribed in a circle. Skip it if you had it on a test, yeah. CMNQ. CMNQ is concyclic. So the angles added up to 180. That is the important property. Daniel, I don't know what you're talking about. Why is that? Yeah, Daniel, can you please stop, or else I'm gonna have to put you on mute for a while. Geometry, my least favorite form of math. Geometry is a great one to get past drawing lines on triangles. That's kind of how I feel too. I'll try these problems to try and help people, but I don't particularly enjoy these problems. Look, 60 degrees, MCM is roughly 45 degrees based on a short look QED. Yeah. Angle MCN. What's the idea? Because I'm struggling to think of an idea so far. Draw a circle around the triangle? Okay. Not my best circle, but sure. We can put a bound on the angle 0 between 0 and 360. It's truly an approximation of a circle. Yeah, I mean, anything is an approximation of the circle if your error tolerance is big enough. Oh, yes, yes. Oh, thank God that you're figuring out, Ishan, because I'm sure not. Draw a tangent on the point B. Okay. Let's fix the circle a little bit so it looks a little better. Or else when I draw the tangent, it'll be more clearly a tangent. All right. Name the other point of the tangent D. All right, I'll just put... I'll just take it on the upper part of the tangent, I guess, like there, D. DBC equals BAC. DBC. Oh, angle DBC equals angle BAC. Because it is inscribing the same arc. I don't see that, but if you're if it's just my poor drawing or me being bad at geometry, then I would trust you over me right now. Alternate segment theorem? Okay. Well, hopefully the math works, but if you're doing math that doesn't work, then I don't really know what you're doing. But yeah, for whether math should be useful or not, that's certainly a debate that can be had. Hey, Ninod. I'm 27. Perfectly happy studying useless mathematics. Sometimes it's there's some neat problems, but I definitely prefer the applied math. Oh. So maybe I should have drawn the point D on the other side of the tangent, but I can see the theorem you're talking about now. Your English is useless as it seems. No, your English is great, Yanis. I mean, it's way better than I could ever hope for to speak a second language. So. Your solution is wrong? Ah, dang. Can you draw the figure? You might figure it out this time. Yeah, let me so Fenlox put something in chat. Let me just see what's up with that. So the way to find the answer here is just be introducing the AC equals BC. And treat the triangle ABC as half a square. If a unique solution exists, then it has to be invariant with respect to scale and the side lengths. By the same factor? I feel like changing the lengths of each leg is going to be a pretty big deal. Yes, I imagine that it will be a big deal. This corner looks terrible. I feel like that would change it if you're... How would you show that it's invariant to changing the side lengths? Because that seems like a big deal. But I think it's amazing the tensor product in the functor, or right left to joint, and what fun properties come with that. Many indirect applications. You guess you don't really care about that. That's fair. I mean, applied math comes from pure math, so there's always that argument to make about why pure math is worth doing. Purported unique solution is a kind of cheat way. So we haven't actually proved that the solution would be unique, Fembox. We were just kind of taking a shortcut to get an answer, which I wouldn't blame you for. Or do you actually know that a unique solution exists? Oh yeah, Zach, it's kind of covered up by the problem right now, but yeah, I'm going to start on Anders' cats. We're working on this pretty tough problem from a person over in the YouTube chat, though. We're joining PN. All right. To be honest, this person is more just like walking me through it, though, because I'm not contributing anything at all so far. Or at least I'm trying out this person's ideas. So we're going to join PN this time. In QM, okay. Oh, I didn't redraw Q. They look perpendicular, but I'm sure they don't have to be. CQMB. CQMB. So that, like, I guess, trapezoid. And ANPC. ANPC are cyclic. I don't know if other quadrilaterals are cyclic, but I can believe you. Two arctan and a half. Intro to Diffie Qs, Oler? What about them? If you're asking if I can do Intro to Diffie Q type questions, then yeah, I can. If you want to learn them, there's going to be a class over the summer about Diffie Qs, which also implies that CMB equals CQB. CMB, CQB, CQB. Okay. Because they have the same chord as base, and therefore the ing will be the same. Okay. I mean, showing work? I don't know what you mean, Oler. Well, if you want to ask a question, feel free to type it in there. I feel like I've already seen you're on another Math Streamers chats, but in case you don't know, there's a whole list of streamers right there. And out of the list, Nsimplex Put Pachinko is going to be doing a Diffie Qs class over summer. I don't know the exact dates if he's chosen them yet, but that'll be a good resource for you if you want to learn Diffie Qs. Feel free to ask me as well. I'm sure it's going to try and gear it to like help people get caught up as well, but It's up to you. More information, I'm sure, will come. Because they have the same coordinate base. Okay, yeah. So I think I'm caught up with Ishan. Although this challenge is completely beyond me. So if I can help you think it through, Ishan, I'm happy to do that. But I definitely can't solve this problem on my own. CNA equals CPA. Okay. Sec angle MCN is 45 degrees, zone says. I guess the person's task is to actually prove that, so I don't know how we prove it, but it sounds like Ishan has an idea. In triangle MCN, MCN is 180 minus CMN. $180 degrees minus CMN plus MNC. MNC. $180 minus 90. Minus A over 2 plus 90. Minus B over 2 equals 45. Okay, well, that's what Zone Ranger got, actually, which I have no, oops, 45. No idea how any of that works, but if that's the right answer and it makes sense to you, I think that's more important. From the 1995 Britain Olympiad. That would explain why I have no clue how to solve this. I'm glad that you were able to get there. Show the viewers the solution if it's on YouTube. Oh yeah, after my YouTube, or after I turn off the YouTube stream, I'll go through and like copy problems down for like the timestamps and stuff. You don't know if it's there? Okay. Yeah, I mean that might help get this a little bump in views if people search for it, but either way, that's an interesting problem. I just don't know any of the tricks involved for these, so I'm glad you were able to get there and I guess use me as someone to like explain it to. Okay. I've still got, I guess, like 1.5 cats to draw, and then there's a couple of things that I love to do in like kind of the downtime. I'll wait for another problem from chat. And thanks, Ishan, for coming by and asking a question as well. If you have more, let me know. But if there are going to be more Olympiad questions, then I almost certainly can't do them. So it's my caveat. Calculus, I know. Combinatorics, I'm pretty shaky on. I'm not too good with combinatorics. I'll say my emphasis in general is like homework help. If you're doing competition level stuff, I generally can't help with those. If we're talking about like, you know, university level calculus, generally, yeah, I can do that. Combinatorics, I'm pretty bad at, but there are other people around who are better with it. If you know twitch.tv, there's a whole little community of people who are better with combinatorics than I. Ian Stuckey's probably the best one. Real analysis. I know a bit of real analysis. Like I'd say like about a first semester real analysis class is the knowledge that I would have. Linear algebra, Oler asks. I only know very, very basic linear algebra. There's almost always people in chat who like linear algebra and know it better than me. If you have a question. Derived quadratic equation? I don't know how that works. I don't know if I want to do that. Functional equations? I don't know what a functional equation is, I guess. I assume that's something that's like maybe advanced. I don't know that exact term. I know what a function is, like basically like the vertical line tests like that, but I assume a functional equation is something, it's a bigger idea. Your square solution was using medians instead of angle bisectors. Oh no. A function and find the general form of a function? Well, now I'm thinking like function transformations, which I kind of know. I always forget exactly, like if you do like x plus 3 or x minus 2, that's what you're talking about, but... I'm still not sure if it's basically induction bashing. Okay. Oh, like those. Okay, thank you for that example, Bladwy. Those problems I have not solved. I've seen people in the community solve them, though. Yeah, I've tried to do one not knowing any of the tricks or techniques, and I got lost pretty quick. Can we do this geometry sum using complex numbers or coordinate geometry? I can't. I don't know if generally it's possible. Generally it's possible. I've never tried it on your own. You've seen others do it. Oh, okay. Fair enough. I'm gonna try to still keep up with chat, but I do want to get... Oh, Anders, hey. I was about to say that I want to keep working on Anders' cats using math symbols. So, Anders, so far I started on the first cat. We got a partial derivative curly D, 2 logical ands, and then a double integral for the tail. And I'm trying to figure out the rest. We could do the circle with a plus, like the operator. I forget what exactly it means, but for the eyes, right? And I feel like a sideways 3 is the obvious thing for the mouth. Direct sum, thanks, Bladwy, yeah. We could do an isosceles, or just an equilateral triangle for the nose. The whiskers, they can be ones. I guess we need to figure out the legs. Could do really exaggerated subset symbols, or, I mean, will parabolas count? Hmm. He's seeing 11 in a reflected 11. You sort of see Totoro, yeah. I mean, is there something wrong with 11 in a reflected 11? Those are math symbols too, right? Uh, oh, you know what we could do? I was thinking about using like omega for the legs. How would that look though? Like lowercase omega. That's actually not too bad. We should get rid of the body, but like that, I guess. It looks a little weird. It looks like an udder. I'm gonna be honest. That makes me intensely uncomfortable. Hey, Phobos. No one uses reflected 11s? Oh my god. A, B, C, D, V, parallelogram with A obtuse, M and N be the feet perpendiculars. Use omega for the cat's udders. I hate looking at it. Oh god, another Olympiad one? I don't know if I'm ready for another Olympiad one, Ishan. It's not Olympiad. If it's still a competition one, I'm not very confident. M and N be the feet. I'll draw and try to continue drawing cats in the meantime, I guess, but I don't imagine I'm gonna be of much help on this one either. I want to use blue this time. Wait, so we have a parallelogram. Okay, so we should not draw a rectangle then. Oh wait, I should have looked at the angles. A obtuse. Okay, good. I got that right by pure chance. Let M and N be the feet of the perpendiculars from A to sides B, C. And CD. I missed that part. M and N be the feet of the perpendiculars from A to sides B, C, and CD. So that one's easy. This one, I have no idea how it's gonna look. I guess it'll be kind of shallow. M and N. Prove that man. That ABC was? Okay. Yeah, my report, it definitely has some battle scars. I did Phobos. It only took me like at least a month from when you suggested it, but I finally did. I finally had energy to even like think about stuff. Um, so triangle MAN is similar to ABC. So we're kind of connecting M and N and A and C. Believe it or not, I have no idea where to start with this one either. Yeah, it kind of sucks. Like I don't have a better like I use this spray like whiteboard cleaner and I just got a whole big like spray bottle of it too, but it doesn't seem to really help with the it seems like some of those things are burned in. Whiteboards much less than chalkboards. All right. Thanks, Yanis. Sleep well. I'll show it on stream for anyone who thinks they might be able to help with this. I almost certainly cannot. It was about metric spaces. Let ABC, let A and B be a subset of X, where X is a metric space such that A complement intersect B. I hope that bar is small. I don't even know. I don't know if this is that readable on stream, actually. I hope it is, but A complement? Okay. Foam covered in chalk is good. So yeah, I definitely don't know how to do this, but I'll show it on stream in case someone wants to take a look at it. It's in my Discord in the math discussion channel. For closure? Oh, never mind. Oh, okay. The closure of A. You know, it's kind of rough because closure also starts with C, so I feel like you could just as well reverse that notation too. Although I think like AC is normally complement. Like I've definitely seen that in other contexts. So yeah, I'm gonna go back to Ishan's problem in a second here, but I just want to show it on stream in case anyone knows how to do this and can give Yanis a tip. So yeah, down there in like math discussion. You've seen it both ways? Oh, okay. Ishan is saying, can we somehow show A and C plus A, B, C is adding up to 180? I don't like chalk because of the texture, to be honest, Oler. A and C plus A, B, C. A and C is a right angle, is it not, Ishan? If BCN is the other 90 degrees, then we just have a rectangle rather than a parallelogram. And that means A isn't obtuse, right? Because it has to be more than 90. Give me sand in a stick and I'd be happy. Oh, the old Archimedes technique. Oh my god, that'd be the perfect thing for Penn Center's Costa Rica streams. Do math in the sand. Integrating in the sun. Yeah. Can we draw a perpendicular from C to AB? Sure. Do it in green. Ah. Dang it. I had a good streak of marker flipping, but I just messed it up twice in a row. I'm still thinking about these cats, too. The implication arrows could be legs. Maybe we'll do that. And then for like the hind legs, I haven't quite gotten there yet. I mean, I guess technically we still have the partial derivative here. Thinking about it. We could do... Ooh. Like sigma? I think sigma would make good, like, hind legs here. I guess an upside down sigma. Okay. I'm going to call that cat 1, I think. You know, I feel like it's a pretty decent cat 1. Now, Andrews does want a different cat as well. Or Andrews redeemed 2 cats, which feels like cheating, but at the same time, Zach also redeemed like a whole scene, and I didn't call that cheating, so... For the second body... Thing like the product, like capital Pi, could be a thing. I mean, even delta could work. Beta would look weird. Maybe we'll try capital Pi. Do something a little different. How do you draw capital Pi? I think it's really just like a rectangle with no bottom. I think that's how I normally draw it. I think for the tail, I want a square root. I think it's just kind of funny. For the head, not cheating. You asked for 2 cats because you want to make sure you didn't cheat. I didn't cheat. This, then we can draw. Okay, this sum was easy, man. It took me so long to figure out. I could feel bad. AMCN. It's concyclic because opposite angles adding up to 180. Okay. Oh, true, because of the right angles. ANM equals ACM. Okay. And AMN equals ACM. Huh. And ACN equals CAB. Oh. Wow. Fair enough, Ishan. Nicely done on that. Try out this exercise. Oh, I don't know if I want to do geometry problems for fun. I'm not a big fan of geometry. I want to help people out, so I'll do it if someone needs help. But even with yours, like I'm not able to be of much help anyway. We'll do capital Omega for the cat's head, I think. You know, clearly, I just want to draw cats, I guess. This cat is going to be a little messed up. We can do a subset symbol for the hind leg. I don't know why I didn't think of that before. And we should figure out something different for the ears and the eyes, right? You can do deltas for the ears, I guess. Cat. You know, since you've done metric spaces, you'll give it a shot. Oh, thanks, Anders, for taking a look at Yanis's problem. Sent a summit in my Discord. It's calculus. Okay. Let's take a look then. Consider the following two statements. There exists a differentiable function g from r to r such that g of x cubed plus x to the fifth equals e to the x minus 100. Interesting. There's a continuous function. You know, this is really two questions in one. This format of question is always like a little weird for me. So that g of e to the x equals x cubed plus x to the fifth. 2 feels very possible if you have like, isn't it just ln of x cubed, like as in ln of x in parentheses and then cubed, plus in parentheses ln of x outside of parentheses to the fifth? 2 seems pretty easy for me to see. 1, I don't imagine there is, because you can't factor x cubed plus x to the fifth as like the difference of two, as the difference of two numbers to the power of 5 or something, or the fifth roots or whatever. Like I couldn't do this, and these even selected option B. Both functions. Oh, continuous! I missed that. Yeah, ln certainly would not be continuous on all of R. In that case, I guess 2 would be wrong. I completely missed that they require continuity. So actually, for 1, they say differentiable. What's up, critical? We can look at this. We can look at it after this one. Differentiate both functions and created a mess. Sounds good. Yeah, sure. Critical. G. Oh, Zach is saying. Oh, I guess so. Which is always positive in the denominator except x equals 0. So I'm not sure how that helps us. I can write out that derivative. Oh, I see. You're just... Oh, I get why you would want it to write it, because they ask if it's a differentiable function. Okay. So we can just prove it's not differentiable no matter what you do. Then we'd be in business. E to the x minus 100. Okay, so yeah, if you derive it, basically doing d by dx of each side. So d by dx of g of x cubed plus x to the fifth equals d by dx e to the x minus 100. Derive that with chain rule, you get g prime x times 3x squared plus 5x to the fourth equals just e to the x. Divide over that to isolate. Sorry, that's g. Oh my gosh, I messed that up. G prime x cubed plus x to the fifth. Divide that part over to isolate g prime. Three x squared plus 5x to the fourth. And that isn't defined at x equals 0, I think the point is. So there is no differentiable function. Is that what we're saying? Differentiate Fembox? I know. No chain rules needed. Sounds good. Critical. Will do. G prime of e to the x. I think the chain rule is needed for for both of these, right? No, Yanis went to bed, Anders. If you're able to explain it back, I guess in the Discord, or if you want to put your thoughts in chat and I'll like transfer them over to the Discord, I guess, but yeah, it's late for Yanis. So Ishan, if we go with what you said with saying g prime of x cubed plus x to the fifth equals e to the x, you would get that there is such a function, and I think you shouldn't. So can we say for 2, this, I mean, they're asking continuity for 2. I don't know if the same differentiation approach would work. G prime 0. Oh, I see, Anders. Yeah, I'm not sure. Maybe the next time that Yanis is around. I'm not sure when that'll be. So that's from using the chain rule, doing what I did on the whiteboard, Ishan. I repeated e to the 2i pi or Zach's work over on the whiteboard. It's because if you do use the chain rule, the derivative isn't defined everywhere, and that's the issue. It's not defined at x equals 0. Yeah. So for the second one, I'm still not sure, like, if the same approach works for part 2. E to the x is never 0, so you might say yes, but that would mean B was the answer, and I feel like you said that B isn't the answer. So 2 can't use derivatives? Okay. I guess what I said for 2 initially is that the only function I can think of where this is true is ln of x in parentheses cubed plus ln of x in parentheses to the fifth, and that's not defined for all r. True continuity doesn't mean differentiability, yeah. That implication goes the wrong way. Okay. So I don't know if we're able to rule out some other function, or like every other function potentially working, but. Real analysis strikes again. It does. Just keeps coming back. Yeah, Nikas, it was a redeemed from Ethitway or Zach. They're in chat. I'm in the process of drawing two cats right below it, but my webcam is blocking it. Plotting a graph is trivial. You want a function that is increasing at a certain point, but the derivative might be decreasing. Well, I mean, proving that it exists means you just get an example. And you'd want to find a derivative that is positive but decreasing. So you'd want some kind of concave down function that's still positive. So oh yeah, true. X cubed, that should work. If you take the negative part, right? Milk piecewise ln stuff. I guess if you can make it continuous, sure. I don't know if you're able to handle x equals 0 though. That might be tough. I'm not sure. So yeah, Ishan, I don't know like what you would want for an actual math proof for a question like that, aside from just getting an example. Like if you're just proving that such a thing exists, showing an example is usually sufficient, I would think. But I think Ishan's moved on to another question that was on the screen anyway. Like, yeah. Let me erase this on the board. Do a sigma for the mouth. Do equal signs for whiskers. I don't know how I didn't think of that. Oh shoot, critical posted questions too. Yeah, Ishan, I'm gonna have to start switching between people because there's some critical tests a question too. Let me see what yours is though. Because normally critical's doing something else while they wait. It's just saying if these are true or false, or... Oh, true or false, yeah, okay. I think 13 is true because we're given that g of x is differentiable. Obviously false. What? 13 is obviously false. We just showed it. If x cubed the derivative of x cubed is always positive. It's 3x squared. G of x is increasing. Didn't you say that the derivative is decreasing? X squared sine 1 over x. Well, that's not defined for r to r. That's not defined for x equals 0, is it? I don't think that example applies. Hey, Christian. No, I graduated with a bachelor's in applied math a few years ago. I've been a tutor, and I'm planning to go to grad school at some point. But right now, I guess I'm basically just doing this for fun. So yeah, Ishan, to your example, I'd say that's not a function from R to R, I think. Trying to bachelor's of math in CS. Oh, nice. Shooting the college you want. Good luck. You're doing some advanced stuff if you're not even in college yet. I'm trying to get a couple things that I have to juggle. In high school, when you're doing this, I mean, you're going to be pretty set once you start studying math, I guess. You're going to have a big head start. Oh, you know, g of x isn't... x squared sine over x is not differentiable at x equals 0. I don't think that's why your example works. Also, it's not R to R, but that's like a more direct thing. I'm reading your response on the side as well, Anders. Well, what is it for x equals 0? Like, it's not defined for, Are you saying that it's... Sorry, Anders, I'm talking to Ishan with this thing. Removable discontinuity. Oh, with this one, it might be removable? Is it differentiable there? Anders, I read your thing, not knowing what a lot of this means. Well, I mean, I guess I kind of know, but the way the sentences are constructed looks good to me. Since I don't know the math that goes into it, I have a hard time. saying much more, but it looks good to me the more that I read it, and the more that I try to understand. So to Ishan, differentiable functions that g prime x is positive for some x equals a. Is it? So if we did have x squared sine 1 over x as our counter example, why does this break it? (13) is equivalent to the sign-preserving lemma for continuous functions. I'm not sure. Pablo derivative? Oh yeah, true. Minus... Did I get that right? Oh, this is what you plotted, isn't it? Squeeze theorem? Or just saying squeeze? Why did I put the 2 there? G prime x is positive for some x equals a, then it's increasing for some neighborhood of a. This is apparent there. This is a counterexample that Ishan has brought up that would say that 13 is false. So looking, anytime the blue curve is above the x-axis, we want to find a section where the red curve is decreasing. I don't see where that's happening. Yeah, I guess that's a good, Ishan, what would you say your point for A is in this counterexample? Because I don't see where it would be. Is it? Will you plot it? Okay, sure. Mm. x equals minus point 0.0638. Ah. Oh my god, please. Okay, so the derivative is positive here. And the function is increasing here, right? It's increasing in the neighborhood, or there is a neighborhood where it's increasing. Why does the derivative being increasing or decreasing matter? Just because the derivative is positive, right? Hey, SPQ. So I'm misunderstanding the question again, but... So yeah, sure, I agree the derivative's decreasing at this point. But I don't see how that contradicts the question. Because it's still positive. Yeah, 13 SPQ. I'm assuming that 13 is true. So these are all true or false questions. Ishan over in the YouTube chat has put forward x squared sine of 1 over x as a counterexample. I'm not understanding why it is though still. Check again how you define the derivative. 2x sine of 1 over x. 1 over x derives to negative 1 over x squared. Oh, did I reverse these? Oh my gosh. No, wait. I derived x squared and then I derived sine. I think this is right. Because 1 over sine derives to cosine. 1 over x derives to negative 1 over x squared. And so Ishan is saying that at this point x, the derivative is decreasing. But I don't think the question cares about the derivative being decreasing as I read it. Or like, you know, it's true, the function is decreasing here, but I don't see how that's relevant. I mean, like here, the derivative is positive. And it certainly is positive up here. In g of x, the initial function, there is a neighborhood where it's increasing around here. G prime is continuous, this would obviously be true. But we know g of x is differentiable. Does that imply g prime is continuous? I guess not. Okay, yeah, fair. So, Sean, I don't know what else to tell you for 13. For any neighborhood of 0, you see the derivatives going up and down at a very rapid pace, being exactly 1/2 at 0. So now you're taking a neighborhood around 0. You're making the claim that exactly at 0, the derivative is 1/2. Which that element's a little bit tricky. How does the cosine of 1/x behave when x goes to infinity? Oh, when x goes to 0, rather. Well, okay, even if I take you at your word, the derivative is positive there. Counterexample, g prime is continuous. This counterexample, g prime is continuous, so there exists an interval x minus epsilon x plus epsilon where f prime is positive. Oh! Which would mean that g of x is increasing. I like what SPQ was saying. I'll copy paste over to the YouTube chat because if your derivative is continuous, I think it's just a done deal. Like 13 has to be true if the derivative is continuous. Hey, Reme. So yeah, Ishan, I don't have all day to spend on these, I guess. I do have questions from Critical who's been waiting on me. I don't know how much more time I'll be able to spend on these without trying some of Critical's problems. So yeah, we can try and quickly talk about like 14, 15, and 16, but I can't. I don't want to have like a drawn out debate until I've helped out Critical a bit. So 14 at least says g of x is a differentiable function such that g prime x is always positive. Hey, Critical. I'm just gonna try and quickly talk about these last 3 questions and get to your questions soon. All right, so I was looking at 14 a little bit. My instinct is no. I have a hard time actually proving it, or like saying why though. I feel like the sum would not necessarily converge. It could like oscillate or something. Summation of -1 to the n over x to the n. It's diverging. Summation graphs. Oh, yeah, I was doing some summation the other day. You'd sum it from n equals... No, they're not Anders. I did that intentionally. Because YouTube is kind of weird with copyright. Oops, not to infinity. You plot it from n equals 1 to x of -1 over... Oh, well, that's not exactly what I was... Yeah, well, what would... I'm gonna look... From n equals 1 to infinity. Yeah, how do we do this in Desmos? It's almost like a power series. I guess it'd be x to the n. Oh, it's more like n to the n. What you're graphing, like the x's will go away in this one. -1 never actually do the trick, really? Oh, for what you posted to Yanis, I did look at that. The English to me made sense. I can't quite follow the math, but the English was okay to me. So you can generally plot a summation like, why isn't it plotting? Okay, yeah, you can generally plot a summation just like that. But a summation like what you're saying, like, the exact thing you put is like a power series, which I don't know what you do with, but I don't think you have x to the end here. You have, n. Like, RSPQ put this suggestion in chat, which this sum is definitely diverging. Because they're asking about g of n, so I don't think you have x's anywhere inside your sum. See, I think 14 is wrong. 15, if c sub n is an unbounded sequence. This is clearly wrong, 15, right? Like, there's no way this is true. We can just use c sub n equals n, I guess. Then the integral from 0 to 1 of 1 over 1 minus x squared, is that arcsine is finite? Which I think it would be. Because I think that's just the formula for arcsine. And that's finite from 0 to 1, I think. So yeah, I'll confirm that last one, but after this I'm gonna look at Critical's question. Yeah, it's just arcsine. And arcsine is defined between 0 and 1. Okay, so yeah, Ishan, if you do have anything else, I'm gonna have to get to it later because I want to look at Critical's question. questions, but they should be shorter than like 13 that we're just looking at. Okay, see ya, Ishan. Hope you sleep well. Use any test to determine whether the series is absolutely convergent, conditionally convergent, or divergent. Critical isn't here yet, so I won't like go and start writing things on the board yet, but we can figure out what we want to do for these. Oh, you are here, critical, okay. So... this one's an alternating series. What happens with the alternating series test? Ooh. Okay. I think the alternating series test is going to be our friend here. Sorry for the wait. Critical. Going from n equals 2 to infinity. Right. So this series is alternating, so let's try out the alternating series test before anything else. N is greater than ln of n for large n. So it's decreasing. And then to do the limit, as n goes to infinity of ln of n over n, here ln of infinity is infinity, and we get infinity over infinity. So let's apply L'Hopital's here. The limit as n goes to infinity of 1 over n over 1, which is just 1 over infinity, which is 0. So this thing converges by alternating series test. I mean, if you have anything on that, I'm going to start writing down the next one, though. One to infinity minus 9 to the n over n 10 to the n plus 1, right? Hard luck with the 4 bits. Thank you. Hey. 1 plus 1 equals 2. I get it. It was hard to see at first with like the space between the bit like symbols. All right, so for this one, this looks a little bit like a geometric series. I'm gonna try and get it to look like a geometric series. So the issue is that this 10 is to the power of n plus 1. So I'm gonna rewrite that as 10 times 10 to the n. This is just using exponent rules, because if you multiply these back, you add the exponents. That's 10 to the 1, that's 10 to the n, so you get 10 to the n plus 1. We haven't actually changed anything about the problem, which means we can now group this negative 9 to the n and the 10 to the n. This might not be necessary to the problem, but I think it's going to help make things look a bit nicer. So prove it. That's why you hear you can't. There you go. We can also bring out a -1, or this negative sign can come out of the series as a -1 to the n. Or it's still in the series, but it can come out of those parentheses. So I'm going to put it right there. Now what? We have this little bit here is a convergent geometric series. That bit is the harmonic series, and they're multiplied together. I don't know if the alternating series test is going to be our friend for this one, because I don't know how you evaluate this limit as n goes to infinity. It might be 0, to be honest. Maybe alternating series test does work, because 9/10 is less than 1, so that limit as n goes to infinity should still be 0, right? Or it will be 1. It will be... Why can't I do math? It'll be 0. And 1/n should also go to 0. Hey, Sing King, formula for a minus b squared. You learned ratio tests and root tests. Ooh, okay. Those might come in handy if we're allowed to use those, like, especially for this one here. Let me quickly address Sing King's question. So you want to know a minus b squared? I would write this as a minus b times a minus b, because that's what it means to square a number. You multiply it by itself. And now this makes it a bit easier to look at to multiply these out, at least for me. So I always do it as I take the first letter here, I multiply it by the other two. So I do a times a is a squared. Then I take a times negative b is minus ab. Now we go to this negative b and multiply it by the other two. So negative b times a is minus ab. And negative b times negative b is positive b squared. Combine the two minus ab's, you get a squared minus 2ab plus b squared. That's how I do that. Yeah, so I might ratio test to this one, critical in that case. Because I think the alternating series test works, but the limit, evaluating the limit is a little bit tricky. Oh, you're still here, Ishan? I want to focus on answering Critical's questions that are in front of me here, but I can talk about it more after these questions, or I can link you to Paul's online notes, which is a website that I really like for everything calculus. I'll link you to this page, but like look around in the sidebar for their stuff on the stuff on series, and I can go through a little bit later if you're still around, but that's like the quick thing that I can link to that I think would be the most helpful. Form of alpha beta. Oh, I mean, you can make those alphas and betas too if you want. It'll be the same thing. But I need to erase this so I have room to go back to Critical's question. So, I mean, we could develop a series test here. It's just not quite as clear to me how you do the limit as n goes to infinity of 1/10 and 9/10 to the end. I think you would split it up into a product of two limits. I think you can safely do that. That's the only part that was giving me like pause. But wait, I just want to make sure I'm getting that graph of that right. I think alternating series test is probably sufficient. We don't have to do the ratio test. And I know the screen capture is messed up right now. I'm just gonna roll with it. Okay, yeah, it does go to 0. So I think the ratio test, it will work here, but you could also just do this thing that I'm showing here, the alternating series test. I didn't write out that it's decreasing, but 1/10 to the n is decreasing, 9/10 to the n is decreasing. If you multiply two decreasing things, you get another decreasing thing. So I think you can say this one converges by alternating series test as well. Oh, you want to see the ratio test as well? Sure. So the ratio test will set up as the limit as n goes to infinity of the absolute value of, I'll use this version of the series, but instead of n, we have n plus 1. Remember your parentheses whenever you plug in the n plus 1 to things. Over the original series. It always looks like a bit of a mess when you first plug things in, but you pretty much always, or you should hopefully get some nice cancellations. So that's how you set up the ratio test. Now let's look for cancellations. So -1 to the n plus 1 can cancel with -1 to the n. We're left over with just a -1 to the power of 1 because 1 is n plus 1. So we get a -1 there. 10n plus 1, it doesn't directly cancel with 10n, so they're going to both be brought along for the ride. So the 10n plus 1 is still in the denominator. The 10n plus 1 is in the bottom of the bottom, so it flips up to the top. And then we have 9/10 n plus 1 times 9/10 to the n. So these similarly cancel, but we do get a leftover 9/10 from the plus 1 there. And so we have the absolute value. N is going to infinity, so n is always positive. All the absolute value is going to do here is get rid of that -1 in front, so let's do that. Make it look a bit simpler. The 9 and the 10 I'll bring out front, so 9 times 10 is 90. 10 times 10 is 100. Now this is a simpler limit to do. I forget if we were doing this a certain way before. You could L'Hopital's it. I'll just use L'Hopital's for this one, I guess. Because it is infinity over infinity, so we're allowed to use it. You get 90 over 100. After you derive it, the ends go away entirely. So it's 9/10. This is less than 1, which means the ratio test, it does apply, and it means that this converges. So this limit is probably a little bit less tricky to evaluate as long as you're comfortable doing the cancellations in this first step. Can you use n to the -1 over n to the -1? Differentiate. You're committed to that, Fembox. I respect it. Where did you say that? Sorry, I wasn't looking at chat. Where is the n to the -1 over the n to the -1? Oh, I see. For this limit at the end here, like here, you definitely could. Yeah, that's a completely valid way to do it as well, if you don't want to use L'Hopital's. I mean, I agree too. I'm just too lazy to change my ways. Do you want to see me do it that way, critical, or do you feel comfortable just knowing that you can do it that way too? Okay. So I'll move on to 31 then. Okay, sounds good. Yeah, this one, I always have a hard time explaining limits like these because there's so many ways well, not so many ways, but there's a couple of different ways to do them that I think are equally good. So I always kind of struggle to choose one to explain. Okay. So what's up next? Oh, like if the ratio test shows... Oh, I forgot about absolute convergence. Oh my god. I need to read the instructions. I forgot about that. And I need to look up if the ratio test gives you absolute convergence or just regular convergence. If it does give absolute convergence, probably better just use the ratio test as much as possible. I completely forgot that we're supposed to test for... everything that I did just then was just regular convergence, not absolute or conditional. Say I forgot. Read the something question. Read the fucking question, yeah. Okay, ratio test is great for these problems because it's absolute. It proves absolute convergence. So in the work that I just erased for the second, or like for this one, I would use the ratio test part. I'll read the full question. I think read the fucking question is funnier, but yeah. For this one up here, we did not prove absolute, or we proved that the alternating version converges. The I bet this one is conditionally convergent, but also read the fucking question. Okay, so we need to revisit 27. How do we want to show absolute convergence? The ratio test, I don't think helps us here. I think we get 1 for the limit. Hey, Sing, I'm not sure what you're talking about. Alpha, if you have alpha squared plus beta squared, that doesn't really factor. Yeah, so for 27, I only showed that I didn't test for absolute versus conditional convergence. I'm thinking about the absolute value of this series and trying to prove, well, I don't think it's, I think ln of n over n without the -1 is going to diverge. I bet this is going to be conditionally convergent the entire thing. I'm not sure how to prove it yet, though. Oops. Sorry for the shakiness. Does the limit? No, the test for divergence doesn't help. So I gotta work on this series right here. Or like, can we do integral test? It has to be positive and decreasing. Is this possible to integrate? Ooh, it might be an integral test. So yeah, I think we make the claim, this is always positive. It's always decreasing because n increases faster than ln of n. So I think the integral test applies, and the integral isn't too bad, I think. Because I think we do a U sub with... Did we have this exact one and this exact thing didn't work? You're a little scared that we don't get the cancellation that I'm hoping for. No, the X's do cancel here though, right? I don't remember what we were doing before that didn't work. But here I think we get just U, because the 1 over X is going to cancel with the X there. What were we doing before? Was it... No? I'm getting paranoid that I'm missing something with this U sub, because I feel like a similar problem came up with critical before, where I thought we could integrate it, but we couldn't. Let me just quickly plug it into Wolfram, make sure that I'm not crazy with this U sub. No, it does work. Okay. I forget what we were doing before then. So yeah, U integrates to 1/2 U squared. I'm going to unsub and bring the bounds back. It's the messiest ln I've written in my life. It's actually a stretch. I'm sure I've written messier. Okay, and this diverges because ln of infinity is infinity, so the integral diverges, therefore the original series diverges. So I would say this is conditionally convergent. When is the time to use integral test? Yeah, that's when it would apply. That's when you're allowed to use it. I thought to use integral test because everything else I tried was a dead end. I couldn't think of anything to compare it with. I couldn't think of how the ratio test would help. I couldn't think of like a limit comparison. So I kind of exhausted every other path, and then I thought about the integral test personally. But you can see it took me a while to solve that question, so maybe I should have thought of it sooner. But yeah, we are allowed to use the integral test here because n increases faster than ln of n increases. And so n is on the denominator, which means that entire thing decreases. Okay. So if you're good with that, can I move on to 31 then? Or do you have any questions before I go to the next one? Yes? Okay. 29? Oh, for 29, the work that I did before, it is fine. The ratio test proves absolute convergence, so the ratio test worked on this one, so you can just say that it converges absolutely. And the more I think about it, the more you didn't have to do the rearrangement thing that I did on the original series if you're going to use the ratio test. You can just plug this thing. You can plug n plus 1 directly into this thing, into the ratio test like that too, if you prefer. The ratio test, it always proves absolute convergence. I believe the root test does as well. Let me check it though. So if the ratio test works, you automatically know that it's absolute convergence. So to be fair, for 29, I did do both alternating series and ratio test. I would throw out the alternating series test and only use the ratio test. The root test is the same way as the ratio test. So if you use the root or the ratio test for questions like these, you can save yourself a lot of work as long as they apply. Because those go straight to proving absolute convergence, so you don't have to do the weird stuff that I just did for 27. Looking at each part of the series separately. Okay. Sure. All right, so this one, I see that everything is just kind of raised to the power of n, which makes me think root test, because we can get rid of that power. The root test is pretty rare for it to be helpful, I found. Okay, so this is our series, and this n right here, just kind of being on the outside, makes me think that applying the root test is gonna make that n go away. And I don't know how else we can deal with that exponent of n. It makes things super weird. So let's try the root test first. So I think limit as n goes to infinity of our original series to the n, all to the power of 1 over n. And by exponent rules, when you have an exponent to an that's bad for phrasing, but when you have two exponents like this, they multiply, and n times n, 1 over n is just 1. So they cancel, and we get just n over ln of n. Wait, does this become 1? No, it shouldn't. This one, we can L'Hopital's it, because we get infinity over infinity. And it differentiates to 1. ln of n differentiates to 1 over n. Unflip the fraction, and you get just n. So you get infinity, so this thing diverges. So I'd say the original series diverges by the root test. Make sure that those are the rules for the root test. The other time the root test doesn't apply, I think, is if you get 1. Yeah, for this one, if there's an n exponent on the outside like that, it's either geometric or it's a root test. So I guess geometric is another way that you can deal with it. Yeah, the root test has the same rules. In tech, okay, I didn't leave it off, but just to be clear, there is an absolute value right there. It's just that everything here is always positive anyway. The absolute value doesn't matter. But there is technically those absolute value bars there. Right. If you get 1 as a result of your limit, you have to try another test. Awesome. So unless you have anything else, I'll start writing down 33. 33 is really hard. I see the trick. But yeah, if you don't see the trick, I would be stumped on this one. -1 to the n arctan n. Over n squared. Okay. So, ratio test, like, maybe it works, but who the heck knows what arctan of n plus 1 is going to do with arctan of n. What I would remember first is what the graph of arctan looks like, which, okay, but I'll draw like this. Tangent looks like that with the vertical asymptotes. Arctan is this reflected across y equals x. So arctan looks like that with horizontal asymptotes. And the important bit here is that it's bounded in the exact same way that sine and cosine are. This is bounded at pi over 2. Because this is x equals pi over 2. That's y equals pi over 2 there. And so you might remember the trick that we can do here now. Squeeze it, yeah. I would just call it comparison test, but yeah, that's basically squeeze theorem. So based off of this, I would make the claim that arctan is bounded above by pi over 2. And I do see an n squared here, which is a p series with p greater than 1. So I'm already suspecting that scene is going to converge. So if we use the comparison test, we want to bound arctan from above so we can get a series that's greater. So let's write down the original series again. Is less than or equal to the same thing. Oh, I forgot about the alternating bit. I'm going to prove this is absolutely convergent. We're able to. Oh shoot, man! I forgot that's alternating. I should have addressed that bit first, but my mind goes straight to the arctan and trying to bound it. So we can prove that it's absolutely convergent, or we can prove the absolute value converges, so the entire thing should converge. So I'm going to bound arctan of n by pi over 2. Pi over 2 is just a constant. It can even come out front of the series if we wanted, because it doesn't involve n. 1 over n squared converges because it's a p series. So I'd say it absolutely converges. By the comparison test. You could try the alternating series test first, because it is alternating. I don't know how that limit evaluates. You should get 0. Yeah, because arctan of n is bounded, and then n squared is unbounded. So you're dividing 1 over infinity, or pi over 2 over infinity. So if you did apply the alternating series test, it would check out too, but it wouldn't prove the absolute convergence part. So you could cut straight to the chase, considering the not alternating series, I guess. That's a pretty poor way of explaining it. I'm sorry, because I forgot that it was alternating. Guess never Zach series class, you can get better at all this. I really enjoy these questions. I think it basically is just a squeeze theorem. We just write an implied like 0. Yeah, comparison tests critical. Hey, Pro Alex over on YouTube. 1 + 1. I think it's 2. So yeah, this is a tricky one because it really is the exact same trick as we've been using for sine and cosine. Because sine and cosine are bounded by 1 and -1. But it's really easy to forget that arctan is bounded in the same way. If you had just tangent, this would be a much harder problem. I don't know how, I doubt it would converge, but it'd be difficult to prove either way. Yeah, exactly that. Critical. So yeah, that's what it looks like with the horizontal asymptotes drawn in. No, no worries. So you have more, feel free to keep them coming. I might take a quick bathroom break here, but yeah. Um, yeah, actually, let's take a quick break. I'll be back in like just a minute, and then we'll figure out what to do after that. read as far as Gauss' Law and the Parcel Text. It's a good book. I completely agree, Henbox. I've started to read it. It's it assumes a lot of the reader, which I think I'm keeping up so far. How far am I? Yeah, what's up, Critical? I think I just got to the end of 1.7 here. Yeah, I was about to go on to 1.8. So I don't think I've gotten to Gauss' Law yet. We use the comparison test, yep. Oh, you know, there was one part in the book that I think I know what it's saying, but the phrasing of it was super weird. Where is it? I guess to me it was weird. Okay, so their explanation for why positive and negative charges aren't a very good, like, name. This statement really confused me. I think I know what it's trying to say, but the actual phrasing of it, I think, says the opposite as I was reading it. A negative integer, once multiplication has been defined, differs essentially from a positive integer in that its square is an integer of opposite sign. Their squares have the same sign, don't they? I know what it's trying to say, where like you can't multiply two negative charges to get a positive charge. But I feel like this is the exact opposite of what they're trying to say, unless I'm misreading it. Which one must be convergent in order to say it's convergent? A sub n or B sub n? Well, the naming there is tricky. You can technically take any series you want as A sub n and any series you want as B sub n. But, you know, we usually just take whatever series we're given as A sub n. And if you want to prove that it's convergent, okay, yeah. So if you want to prove that A sub n is convergent, you want B sub n to be greater than A sub n and also converge. Those two things have to both be true. Oh, I see what you're saying, Fembox. Yeah, that makes sense. I think they're saying positive and negative integers squared to have different signs from each other, but from themselves, that's certain. Or for negative integers, they certainly do square to have a different sign from itself. Oh, well, it's gone. Modulus 4810 followed. Thank you so much. Divergent. So we're still taking A sub n as the series we're given. In that case, you want to name a series that is less than A sub n and also divergent. It is weird. I think about it graphically, to be honest, where let's say you have any series you want, and we graph it, and it, you know, the partial sums look like this. We don't necessarily know how this behaves, but if you suspect that this thing converges, you name any other series you want that is greater than it and also converges. So let's say the series we're naming in red here is always greater than it, but we know for a fact that this red series converges. That means that this black series below is boxed in. like underneath this red series. So this black series must also converge, because it can never, if it diverges, that means it somehow shoots off to infinity. But that can never happen because it's boxed in by the red series. That's how I think about it in a very like visual way. And the opposite is true if you want to show that it's divergent, where if you have a series with partial sums, then you think it diverges, so it's going up to infinity. Name any other series that's less than it that you know diverges. And since this red series diverges, the black series is forced to also diverge because it can never suddenly start behaving super nicely and leveling off, because the red series forces it to always shoot up. That's how I think about it. What's that cat doing playing inside the cannon? Pretty dangerous. Yeah, Fembox. I need to finish off that cat. It needs a nose and it needs the front legs, and then I'll be able to take Andrews's points. Yeah, I tried to use capital Pi as the body of the cat there. It does look like a cannon though, you're right. All you gotta know is B sub n status. If it's smaller than A sub n and it diverges, then it diverges B sub n. It's greater than A sub n. Exactly. The entire point is we don't know how A sub n behaves. We're just going to, you know, box it in, or the fancy word is bound it by another series whose behavior we do know. And that forces the other series, you know, because we're not saying exactly where it goes. We just care about convergence or divergence. So for these purposes, at least. So I hope that helps you picture it a little bit. That whenever I try to set my comparison tests, I kind of have that image in the back of my head. Hey, Scorpra. What is that emote? Oh, it's a global emote. I haven't seen that one before. That's funny. um... Hey, Cosmolano. Go ahead, Critical. You have this idea for something, but you don't know what it is. Do you think you can help if I describe it? Maybe, yeah. I feel like you do some stuff that's pretty beyond me, but I can try. You know, I should update my reading group command for what it says. I'll do that. I'll write it down and do it after the stream, though. Add, update, reading group. Okay. Still thinking about the cat that I have to draw too. Yeah. You know what? Okay, I want to get it off my mind. I'm just gonna give the cat a square nose. So I can't think of another symbol that's more like a cat nose, so it's gonna be a square. Then the leg, it's gonna make it a parabola. Who cares? Okay. And I'm gonna take screenshots of those and take the points and all that. Give me 1 second while I take a screenshot. Post it on Discord. All right, I'll take a look in a second. Then let me get one more screenshot. Ah. Okay, there. So I want to get those drawings off my mind. I'll look at what Cosmolano was saying first, then I'll look at criticals. So first, you agree with the claim that a vector field can be conceptualized attaching a complex number to each point in space. Yeah, sure, critical. Attaching a complex number to each point in space, as in a point on a circle of some radius. Yeah, I haven't done that before, Cosmolano, but I can. If you're as basically just using a complex number as a vector, I guess, which I don't see why you can't. Suppose that instead of a point on the circle at each point, an arc on the circle. Okay. We're going to change the arc from point to point. Not a field vector anymore, so what is it? It's like there's a fourth dimension involved here now. Or it's like, I guess, an extra dimension that gets involved or something. Because I assume that both how far away the arc is, the direction it is, and then the length of the arc are the three things of interest, where it's just a vector, you care about direction and length. Like, what's the name of this thing? I definitely don't know that offhand. Or like, do you think this is something that is like named that you're just trying to find the name of, or do you think it's like, I guess maybe you wouldn't know if it's original or not if you just thought of it. I mean, I'll just start Googling stuff. Enders, yeah, I did. I posted them in my Discord even. But they're still up there too. I could take a better picture without the glare later, I guess, if you really want. We're interested in attaching a hemisphere to each point in space. Specifying an area on that hemisphere, a photo instead of a screen cap. Oh, yeah, I can do that after the stream. I'll post it in Discord and I'll at you. Hey, Linux Physics, Kaluza-Klein theory? Never heard of that. Proposes an intermediate step. Yeah, we'll do Enders. I don't think I'm smart enough to understand what's happening on this Wikipedia page. With each point in space, give me a fifth compact dimension. Oh, okay. That's super weird. Um, That's not like you understand what Kaluza-Klein theory is, and it's not that. Um, so I can see where the similarity is. We used to have arc lengths instead of circles. But want to know what is I'm thinking about specifying an arc on the circle. Yeah. I mean, what else might this be called? Or I'm not sure. This is I doubt it'll be just from this Google search. I probably shouldn't rely on Quora. Man, what if there's some version of Kaluza-Klein theory, since it does seem so similar? Like with the references, or like a. Mm, yeah, honestly, I'm not even sure like what to Google here. um, and this is something where I normally hate saying it, but like this is the type of thing that ChatGPT might honestly know. Let's give some kind of like advice on something to Google. I don't know if ChatGPT how good it is at these like kind of more obscure like academic things though. Really bad. Okay. Yeah, I never tried to ask it about like advanced physics like this is. That was a number theory? I didn't even realize that, Stooky. It is! Yeah, why? What are people discussing it, or are they just like yelling at this person for posting in number theory? There we go. Just by looking at something in Mario 64. Funny. As far as anything was too complicated. Yeah, I was thinking like that. It seems so related since it uses circles. And you're just talking about arcs. Give it attaching sort of each point is more lucid as U1 symmetry. One symmetry. Hmm. Yeah. I start off understanding this stack exchange response, so I got optimistic, and then I started reading down here. It's like, never mind. I no longer feel optimistic about understanding this. Oh, hey, league groups. I remember someone mentioning that these things can come up. Yeah, I'm sorry, guys, Milano. I'm kind of stuck. I don't know what to even try with Google anymore. It's like what I'm hoping is like I guess it would be a range of complex numbers. I was wondering in my head like how you would define this arc. Like, would the direction be the midpoint of the arc, and then you're only defining the length of the arc, so half of it is on. Yeah, no worries. I'm trying to think of someone who would potentially even know, but I'm not sure. Hey, Cyber Rage. So, I wish I could help more, but I'm similarly stuck. Doing the math all right? I'm trying anyway. Yeah, I'm just not sure. Ooh, okay, so I'm switching back to critical now. See, we're gonna have some power series involved now. I said Cybermage. The big E is a Greek letter. It's capital sigma, and we use it to show summation. This is kind of a complicated way to introduce summation, but basically the idea is it's like a more succinct way of Can I just give like the simplest example that I can think of? If you have the summation from n equals 1 to 10 of n, it means you start at n equals 1, you plug 1 into whatever's inside here. Here we just have just n. So we get a 1, and then you do plus, now we do n equals 2, plug that in, plus 2, then n equals 3, plus 4, plus 5, plus 6, plus 7, plus 8. I should have done a smaller number. Plus 9, plus 10. That's what this means. Or like, you know, these two things are completely the same, but this is much more compact. And then when you do a calculus class, you can get concerned with sums that go out to infinity instead of 10. Or you can have more advanced things like sigma n equals 1 to 10 of like n squared plus sine n or something random inside there. But the procedure is always the same. You start with n equals 1, plug 1 in there, and then do plus, and then plug in 2, plus 3, and so on. Like that is the idea. Do you hear critical? All right. Let's get started on your questions, critical. Oh, that kind of looks like a line bundle, unless the arcs are allowed to be the entire circle. I never heard of a line bundle. Cybermage, not necessarily, and that's kind of the whole fun of, well, depending on your definition of fun. That's kind of the entire thing that we're examining here with critical, which if the sum goes to infinity, does it have to go to infinity, or can it be a finite number? And the answer is sometimes yes, it can be a finite number. Thanks for helping out, Stuki. Or, you know, just like giving your thoughts on it too. But yeah, just to address Hypermage a little bit more, I'm sorry, for critical. You could have a one where like the terms are decreasing, where if you have like 1 over n squared, that's going to be 1 over 1 plus 1 over 2 squared, which is 4. I'll actually write 4. Plus 1 over 9, which is 3 squared. 1 over 16, which is 4 squared. All the way out to infinity. Here, each one is getting smaller and smaller and smaller. You're adding on smaller and smaller things. And we don't know exactly what this sums to, but we know it sums to something that's finite. So that's a case where you can potentially not just end up with infinity. Let me look at criticals though, because we're going to do a bit harder of a version of these problems. So radius and interval of convergence for these power series. Tangent bundle of infinite dimension like Hilbert space. Ooh, wow. Fancy words there. So critical. With these, when you have a power series and you want the radius and interval of convergence, or just one or the other, it's always ratio test as far as I know. Technically the root test would work too, or the root test could work, but every time that I can recall as a student that I did these, it was always ratio test. And it's going to be x involved, and that's okay. Oh, true, Fembox. That one actually is solved that I said. Yeah, you're probably right. Power series is ratio test. Basically, yeah, critical. If you're given a power series and you want the radius of convergence and or the interval of convergence, you apply the the ratio test. Now, I feel like you're going to get thrown some curveball that could be the root test or something else that's weird. But as far as I know, it is ratio test. Convergence, Hyrmage, it's that exact thing that I was thinking of. It's if it converges, that means your sum does not go to infinity. If it diverges, the sum does go to infinity. It's just a fancy math way of saying that. So here, critical, when we set up the ratio test, we do have to make sure we're careful about things because x is allowed to be any value for now. We want to figure out what values x is allowed to be. For now, we have to allow x to be anything. So that's going to influence how we deal with absolute values, is why I'm saying that. So first, before we get too deep into it, let's just set up the good old ratio test that we know and love. So we take the original series, plug in n+1, divide it by the original series, absolute value of all this. So the way it should always go with these power series is you have just an x to the n. It might be x to the 2n or something similar, but almost all the time, you should get some kind of cancellation with the x's here when you apply the ratio test. And it'll hopefully be just x to a constant power. I guess it doesn't have to be. Or it should just be x to like x to the 1, x squared. It shouldn't be x to the n. Hopefully the x to the n should always cancel. I think they always do. So I'm going to cancel x to the n+1 and x to the n. We'll get just x. n+1 and n don't really cancel. So I'm going to flip the n all the way up top here because it's on the bottom of the bottom. All right. So all I did here was I canceled the x's and then I flipped that n up to the top. Hey, hello, Jenny. Yeah, math homework help, or if it's easier, math discussion. I'm not the best with linear algebra, but hopefully me or someone in chat can figure it out. Hey, Math Magazine or YouTube ratio test. I agree, yeah. Sorry, I'm not sure when I thought you said that. Okay, so now when you deal with this limit only concerns n. The x is completely irrelevant as far as the limit is concerned. So we're actually allowed to bring this x completely outside the limit, but it needs to get absolute valued on the way out because it's still inside these absolute value bars. So we can say that the absolute value of x times the limit as n goes to infinity of this thing. Or we can say that these two things are completely equivalent because x doesn't care about the limit at all. Those don't interact. We're allowed to bring the x outside as long as it keeps its absolute value bars. So range, what is limit? Why don't you close your brackets? Lim is short for limit, and it's another calculus idea. We're basically considering this function for very large values of n. As n gets very big, how does this thing behave? And why don't you close your brackets? I'm not sure what you mean by close your brackets. These are absolute value bars. They're normally just written as vertical bars. I'm not sure if you mean something else by that, though. Okay, so critical. Now we can evaluate this limit. N over n+1 for large values of n is always positive, so we don't have to care about these absolute value bars. And you can evaluate this limit any way you want. If you like the n to the -1 over the n to the -1 thing, we can do it that way. N times n to the -1 is 1. That becomes 1. That one becomes 1 over n. Oh shoot, we can drop the absolute value bars, like I said. Now when you evaluate that limit, you get 1 over 1 plus 1 over infinity is 0. So 1 over 1. So we get this limit evaluates to 1, so we end up with just the absolute value of x. It's a rank 2 vector bundle. Thanks a bundle to you both. Well, thanks very much for suggesting that then, Stooky. X is not the answer, critical. That's a good question. We've gotten the hard part done. But remember, this came from the ratio test, and the ratio test says that this thing converges when this limit is less than 1. We're interested in every value of x for which this thing converges. So we need to set this to be less than 1. Whatever we get from this limit gets set to be less than 1, and then we solve for x. So if the absolute value of x is less than 1, that means that x is bounded above by 1 and below by -1. And we're still not done quite yet. We can say, even from this step, that the radius of convergence is 1. But the interval of convergence, we've nearly found it, but we need to test endpoints. That's the thing that I always forget with these. Or it's a thing that's, like, in general, people always forget about interval of convergence is they get to this step and they say that we're done, this is our interval, or they might write -1, 1 like that. And I forget if you use that convention for interval notation, but you need to test your endpoints individually. So it might end up being our interval, but we might have less than or equal to for either one of these or both. So what we do is we take x equal to -1, plug it into this series, test for convergence. And then we're going to take x equals 1, plug it into here, and test that for convergence. So we have two like sub-problems now. So let's take x equals -1 from n equals 1 to infinity, -1 to the n over n. I would say this is an alternating series. It's decreasing in the limit of 1 over n as n goes to infinity is 0. So I'd say this thing converges by alternating series test. Which means this less than becomes less than or equal to, because -1 does work. Now to test it for x equals 1, we'll do the same. We'll do the same plugging in. Now we get 1 to the n over n. 1 to the n is just 1. Doesn't matter what power you raise 1 to, it's just going to be 1. So really it's just 1 over n. That's the harmonic series which diverges. So the answer to the question is that the radius of convergence is 1 in the interval of convergence, depending on your notation, is -1 is less than or equal to x is less than 1, or -1 with square brackets, comma 1 with parentheses, or I think in other countries they would say -1, 1 like that, or something. I forget what the notation exactly is, but there's a couple different ways to represent intervals. You can't see the entire... Oh, shoot! Sorry about that. You didn't miss much, though. Oh, yeah, so hello, Jenny. I am looking at your question quickly, and I sure do not know. I see Anders typing, though, so thank you to Anders if you do respond to that. Yeah, that's the part of linear algebra that I mean, I only know very basic linear algebra. Yeah, for the series on the bottom, critical. When x equals 1, you get just the harmonic series and that diverges. The one above, when x equals -1, you do get a convergent series. And like how you interpret this is for any series of this form, it always converges if your x values are in this range, and always diverges if they're not. So you can see it agrees with the harmonic series diverge if you plug in 1 for x. If you plug in 2 for x, it'll diverge, or 3 or 4, or -4, you know. It kind of answers questions generally about series. Whether we were looking at specific examples of series, this looks at like a little more generalized, I guess. The answer? They ask for interval and radius of convergence. The radius of convergence is 1. The interval of convergence is a -1 inclusive, comma 1 exclusive, and your notation for that may vary by country and by class. So these are, it could be denoted like this. -1 is less than or equal to x is less than 1. Like this, square brackets, -1, comma 1 parentheses. Or I think in some countries like that, with both square brackets, but that's one is facing outside. I might have it backwards or something. But yeah, interval notation is a little bit tricky because people have different standards. So if you've seen one in your class, you should go with that one. If you tell me, I can just use that notation as well when I answer your questions. Okay, so critical. If you're all good with number 3 so far, do you want to go on to number 5? All right, let's do it. So we have n equals 1 to infinity. Root n times x to the n. Very random, what do you do down in chat? I think it's the most comfy food for a cold day. Ooh. Soup is always a good one. Warm applesauce? Ooh, that's a good response too. I just like a good like stew even. It's a cold day. Like, and I can hold my hands like on the sides of the bowl to like warm them up. Okay, so for this one, critical, the nice thing about these types of tests is that you can pretty much always follow the same steps each time. So we'll set up our ratio test. Root n plus 1 times x to the n plus 1 over root n x to the n. Okay. Now the x to the n's cancel. We have an x to the 1 left over up here. So I'm going to make the same argument as before and take an absolute value of x out front. You should generally always end up with some kind of absolute value of x isolated out in front of the limit for these. It might not be exactly x, it could be 2x, it maybe be x squared, but it should always be x in some form with no n's involved. That's out front. I believe, at least. So we're just left over with on the inside root n plus 1 over root n absolute value. Square roots for very large numbers are always, and square roots are always positive or 0, so we don't need the absolute value bars. And these have, we can, they have the same exponent. A square root is an exponent of 1/2, so let's write them under one big square root bar. And this is another potentially sketchy limit trick but we know that like this thing is going to converge. Technically you shouldn't use it if you don't know that's going to converge, but what we can do here is we can bring the limit inside the square root. There might be a different way to evaluate this too, but this way is the most natural to me, I guess. And now this limit inside the square root, I think, is familiar to you by now. I'm just going to say that it's 1, but if you want, it's the same, you know, n to -1 over n to -1 trick that we've been using. So that's going to be the square root of 1, and the square root of 1 is just 1. So we get just the absolute value of x. Now we have this simplified as much as we can. So remember that this came from the ratio test, and we need to make this thing less than 1. So kind of the how should I say this? Like the last problem, from this stage, we automatically know that our radius of convergence is 1 as soon as we get into this form. And then the interval, like, you know, our interval is going to be something like -1 is less than x is less than +1. But again, every time we do this, we need to test those endpoints. So let's go ahead and do that. So let's plug -1 back in up top. What the heck are you? Okay, well, the easier one to evaluate is x equals 1. This one I'm a little unsure of, but this one diverges by the test for divergence. The limit as n goes to infinity is still infinity. The alternating version, I'm kind of puzzling about, because it's not decreasing, so you can't use the alternating series test, I don't think. Where does the alternating series test say that this thing diverges? Let's look at how it's actually phrased. It's still, I would think so too, Zone. I'm just confused how we actually say that. Oh, okay. It is phrased carefully here. Of course it is. Sorry, the bottom one says convergence by diverges by divergence test, which is a really awkward way of phrasing it. I'm referring to the limit as n goes to infinity, like just the basic good old test for divergence. So in this section. Here we go, divergence test. You just take them as n goes to infinity, and you don't get 0. Because square root of infinity is still infinity. Why did 2 have separated equations between -1 and 1? Are you talking about... Why do I have these two things here? That's because we have to test the endpoints of our possible interval here. We know that x should be somewhere between -1 and 1 to converge, but we don't know exactly at -1 and 1 how it behaves. So we have to do those cases individually, always. Yeah, every time yep. If they ask for interval of convergence, you have to do that. If they ask for radius of convergence, you don't actually have to. But if they want the interval, you have to test your endpoints. So I did the bottom series for x equals +1 with the test for divergence, or the divergence test. So the limit isn't 0 as n goes to infinity. And the alternating series test still applies to this one. I just almost never use the alternating series test to prove divergence, so it feels weird. But it has to meet both of these conditions in order to converge. If it fails either one or both, then it diverges. And this one fails both conditions, I guess. So we already shown the limit is not 0, so. I should actually look at the, oh, can you do it more simply? Oh, true. It can be for any a sub n. Well, I guess when there's a -1 in there, it still makes it hard to evaluate that limit, right? To me. Applying the divergence test to an alternating series still feels weird, I guess. Unless I'm completely possible, I just don't know what I'm talking about, but... But I should finish up the work then. I'm going to say that this alternating series, it still diverges. I'm going to say by alternating series test, because that's the one that makes, I guess, more sense to me. Maybe it's possible the test for divergence still applies to that one. I'm just a little bit like unclear on that. Regardless, we get that both of the endpoints, it diverges there. So this ends up just being our interval. We have, oh, I was wondering what's happening. Oh, Critical, that's you. Well, thanks so much for the 2 months. I appreciate that. So I'd say our final answer is that the radius is 1, the interval is -1 is less than x is less than 1. Like, neither of the endpoints are included in this case. We still need to check them because they could have been included, but in this case they aren't. Oh, I see what you're saying there, Zone. Okay, so yeah, if I even Paul's notes has this like fact too. Right, I don't know what that limit is, but it sure doesn't converge to one thing. That's 0. Like, that limit is going to diverge. Well, I guess I'm still getting a little tripped up on the mechanics of that, I guess, but that argument probably works too. I just, when it's alternating and it's summed, I mean, I guess, yeah. The terms, we only care about the terms, yeah. Okay, fair. Yeah, I was going to trip that because I was still thinking about the sum, but we only care about the actual terms of it for this like fact here, or for the divergence test. Okay, that's still like weird to think about because like, you know, what if infinity minus infinity is 0? It's not, but when in the concept of sums, I get tripped up on that. Your argument works, so I understand it now. So you don't care that we only care that the terms don't go to 0, and they certainly don't go to 0, and that's as much as we need to know for that one. I'm not going to bother having this in the corner. I'm just going to... So let's move on to 19. We're going to have n over 2 to the n squared plus 1 x to the n. All right, let's copy that down. N equals 1 to infinity. N over 2 to the n. Okay. So, same procedure, set up our ratio test. Do n plus 1 on top here. Remember, n plus 1 is in parentheses. So we get n plus 1 in parentheses squared plus 1 times x to the n plus 1 over, oops, the original series. Okay. A little bit of a mess, but we can get through it. Here we have the good old x to the n plus 1 over x to the n. Let's put our x, let's cancel that and put the x to the 1 outside in absolute value bars. And all the stuff with n is always going to be positive because n is going to positive infinity, and I don't see anything in here that's going to like flip signs or do anything weird. So let's drop our absolute value bars. I don't want to do too much in one step here. Since there is a lot going on with this fraction, I'll write things out in a few steps. So remember that dividing by a fraction is the same as multiplying by its reciprocal. So I'm going to take the reciprocal of this and multiply it. And that I've been doing this kind of mentally the entire time. But since this one's a little bit more complicated, I'll actually write it out. Okay, now let's look for our good old cancellations. Okay, 2 to the n can cancel with 2 to the n plus 1. We still have a 2 to the 1 in the denominator here. And honestly, I don't see any other cancellations that we get off the bat, and that's okay. So on top we get n plus 1 times n squared plus 1. On the bottom we get that 2 just to the 1. We have an n. Then we have that n plus 1 squared plus 1. Okay. So we have this limit to contend with now. You can multiply all of this stuff out and look at the degrees on top and bottom. But we really only care about the degree and what the leading coefficient is. So this is a case where you can save yourself a lot of work if you just look at the leading coefficients of stuff. So on top, we know that the highest power is going to come from n times n squared. You know, there's no way in this multiplication otherwise that we get a higher power. So I'm going to say that the top is degree 3. And not only that, the leading coefficient of that, it's just going to be 1, because we have n times n squared, so it's going to be n cubed, and that coefficient is 1. On bottom, when we do n plus 1 squared, we'll get an n squared out of that, and then we're going to multiply that n squared by the n on the outside here. So we have degree 3 on the bottom as well. So we have an equal degree on top and bottom. This one it has a leading coefficient of 2 though, because this 2 is on the outside. So from here we get an n squared. That n squared is going to multiply with the 2n. So it's going to be, as far as the limit is concerned, we only really care about the limit as n goes to infinity of n cubed over 2n cubed. And that's just going to be 1/2. So I would claim, without having to multiply all the stuff out, that this limit is just 1/2. Because all the other terms don't even matter as far as limit is concerned here. So it's like x times 1/2. And let me check chat, because I hope I didn't lose you there. So I hope that this step makes sense. If you aren't sure about this like leading coefficient stuff, you're absolutely allowed to multiply out the top and bottom and do it the usual way. You would have to multiply by n to the negative 3 over n to the negative 3. That's fine, that's allowed, but this saves you a lot of work. Like just only looking at the leading coefficient of each, because that's all that matters for the sake of the limit. You're following? Okay, perfect. So now we have the absolute value of x times 1/2. So we evaluated the limit. It's as simple as we can make it. Now let's remember this came from the ratio test and set it to be less than 1. So let's isolate x. We do that first by multiplying each side of this inequality by 2 to get rid of the 1/2. So absolute value of x is less than 1. Oh my God. Less than 2. So from here, we can already say that our radius is 2. The radius of convergence is 2. And then we can break out the absolute value to get a potential interval here that we still have to test the endpoints for. So now when we go to test our endpoints, we'll have to plug in -2 for x and +2 for x and look at what those series become. If x equals -2, I get the series n equals 1 to infinity, n over 2 to the n squared plus 1, -2 to the n. So 2 to the n and -2 to the n can cancel. It'll become a -1 to the n. Like, we still have a negative sign there to worry about. -2 to the n, I'm gonna like write as a little side note, is the same thing as -1 to the n times 2 to the n. And the 2 to the n can cancel the 2 to the n, leaving behind just a -1 to the n. Now let's evaluate that series for convergence or divergence. I would apply alternating series test, and it's degree 1 on top, degree 2 on the bottom. the bottom grows much faster, I'd say the limit goes to 0. So I'm going to say this converges by alternating series tests. So that means -2 is included in our interval. So we need to make that less than or equal to. Now if x equals +2, we get this. The 2 t's just cancel. We don't get anything left over. We have to evaluate this. And these are good candidates for limit comparison test, because I don't think the regular comparison test is going to do us much good here. So this series will take a little bit of extra work, but we can do it. So let's apply the limit comparison test. A sub n is our original thing. And the trick for these is degree 1 on top, degree 2 on the bottom is like just degree 1 on the bottom. If you were to, the +1 is messing things up, but if you were to cancel the n with the n squared, you would get just 1 over n. So let's name our b sub n as that hypothetical thing. And now we do limit comparison tests with these two. So n over n squared plus 1 over 1 over n. Let's multiply by the reciprocal of 1 over n. So we get n times n is n squared over n squared plus 1. Now this limit, you can do the same n to the -2 over n to the -2 trick to find this will just come out to be 1. 1 is positive and finite, which means limit comparison test applies, and these two series behave the exact same way. 1 over n we know is a harmonic series, and that diverges. So by limit comparison test, this thing diverges. I'm not going to write series, I'm just going to write harmonic. So +2 is not included in our interval, so I'd say our final answer is that our radius of convergence is 2. The interval is -2 is less than or equal to x is less than 2. Yeah, you can think of it as related to a p-series. You can't directly use the p-series test here because it's not in the exact right form. But if you have a function like that, you can pretty much always compare it to a p-series of some kind. Oh, and of course, Zone comes up with a clever comparison there too. So yeah, there's multiple ways to do limits. I guess I was shown the way that I did it with limit comparison, but what Zone said is completely fine too. You can do whatever works best for you. Last one, 21. All right. Oh, I should say about that limit comparison test trick, you always want to do it as like the p-series are going to be involved, because if you had like n over n cubed or something where like the difference between the degrees is 2 or more, you can still use the same trick. Just compare it with whatever that like difference is, and that'll be a p-series. So down there, we have x minus 2 to the n. Oh, sorry. Hey, to Ahsoka Tano over on YouTube. Evaluate tangent of pi over 3. Let me just answer that quickly. I'll use the unit circle there. Ahsoka. I feel like I've had this issue before with the unit circle not being big enough. How did I fix it? You would look at the pi over 3 radians here, and then for tangent, you always do y divided by x. So you'd set up root 3 over 2 divided by 1 over 2. Dividing a fraction is like multiplying by the reciprocal. So I'd say root 3 over 2 times 2 over 1. The 2's cancel, and you get just root 3. Or you can use a calculator too, if that's what you're supposed to do, but... Taking finals tomorrow, and that's all I'm gonna be. And that's all. You're gonna be a junior finally. Oh, nice, tired student. That's hype. Sounds good. I'll see ya, and good luck with your finals. And no worries, Ahsoka. It's 2 to the n over n squared plus 1. All right, this will look a little bit different. It's a good one to see. Okay, so same procedure as always. Let's set up our ratio test. Hey, Milk. Cell phone on Reddit today if we get bored. Sounds good. If you want, feel free to drop a link. X minus 2 to the n plus 1 over n plus 1 squared plus 1 over x minus 2 to the n over n squared plus 1. Okay. So now there'll be a little trick here, or a little bit different, I guess. Not necessarily a trick, but instead of just x, we have x minus 2, but the same cancellation still applies. We'll end up with an x minus 2 now instead, though, in absolute value bars. And now we get to boil down limit to be just with the n's. The n's are always positive, so let's drop the absolute value bars. I'm going to flip the bottom all the way up to the top and say n squared plus 1 over n plus 1 squared plus 1. So for this one, you could do the same leading coefficient trick that I'll do the same leading coefficient trick that I showed you the last problem here. This one is simple enough that you could just multiply it out too, but just to show it, leading coefficient there is n squared. Leading coefficient here, we know we're going to get an n times an n. The plus 1 won't affect anything, so it's going to be also n squared. So we get just 1. So I'm going to claim that this entire limit here is also 1. get the absolute value of x minus 2. And now we do the same thing where it came from the ratio test, set it to be less than 1 to force it to converge. Okay, so from this step, there's no coefficients multiplying this, so our radius of convergence is still 1. But our interval convergence is going to look a little bit different. So let's break out the absolute value into two different inequalities that are like this. You know, whenever you have an absolute value, you can say that the negative version is over here, is less than your original, is less than what you had. Now, to isolate x here, we can add 2 to, I guess, all 3 sides of the equation. So we do -1 plus 2 is positive 1, is less than x, is less than 1 plus 2 is 3. So it's still like the same length of interval, but it's offset now. That's why its problem is a little bit different. Still the same procedure though. We get to plug in our endpoints and we're almost done. So if x equals 1, what do we get? One minus 2 is -1 over n squared plus 1. This, by the alternating series test, I'm going to say converges because that limit as n goes to infinity is 0. So I'm going to say 1 is less than or equal to x because it's included. Now if x equals 3, 3 minus 2 is 1. 1 to the n is still just 1. So I'm going to write 1 over n squared plus 1. In this, I would compare with a p-series. One over n squared. This thing is a p-series, p greater than 1, it converges. This is bigger than the original thing, and it converges. So 1 over n squared plus 1 gets boxed in, basically, and it must also converge. So actually, both our endpoints are included here. So the radius is still 1, the interval is -1 is less than or equal to x, is less than or equal to 3. Okay, it's absolutely convergence. It's absolutely yeah, I agree, Milk. It absolutely converges. So yeah, is that good with you, Critical? Oh, I see that you posted a Milk. Thank you. Okay. So you think, is that gonna be the last one, like for the night, or just for that set of problems? Either way is fine with me. I just wanted to check. Alternating series test. Because it's decreasing and the limit as n goes to infinity is 0. Oh, and thanks so much, Anders, for helping out with that linear algebra question. I see you two going back and forth. And if you don't know what I mean with that last bit, critical with the alternating series test, let me know and I can draw it out more. Oh. I'm not going to scroll down to look at the answers yet. This is an interesting one. The radius of this circle. How do you find the center? Is this possible? The more I think about it, the more I have no clue how you'd do this. It is possible. Well, you can find the length of the chord for sure from this corner of the square up to that corner of the square if you get our diagonals. I don't see how that helps. We do have 3 points. Yeah, you're right, Stuki. Okay, that's fair. So that defines a unique circle. Good point. It's easy to do numerically. To get the exact answer, take some algebra. Interesting. Oh, I guess maybe you attach coordinates. Because you could get 3 equations and 3 unknowns if you know 3 points on the circle, right? That'd be very painful, as Bane once said. The diagram suggests the answer is 4.5. Does it? 3. Oh, true. I had to look at the scaling with like how wide the 3 is. It does seem pretty close to 4.5. Like the diameter isn't far off of 9. Okay, so I don't want to do the algebra. Yeah, a little bigger. But I think you could theoretically attach a coordinate system here. You know, maybe fix it to like the bottom left corner of this small square and work out what, you know, this point is the origin and work out what the point up here and the point up here are. And then you could set up an equation like for each of your 3 points, x1 minus h squared plus y1 minus k squared equals r squared, and solve for h, k, and r. I don't know if I would enjoy doing that. I could do that, probably, unless I run into some weird algebra thing, but trig. How would trig work? I don't know how you use trig. I mean, well, no. Connect the 3 edges. Draw the unknown radii to them also. like connect to this corner, to this corner, to this corner. And draw the unknown radii to them also, or I guess maybe through them? I guess I can see how to get triangles out of that. The 3 points on the circle. Oh! So connect this to that, back to that. Oh, interesting. I I can see the setup. I'm trying to follow through in my head where you would go after that. I'm not sure exactly what you do with that, but I'm sure there's somewhere that you can go with that. I think I'm ready to scroll down and look at the answer, so if someone doesn't want to be spoiled on this, then you might want to look away from the stream. That's the link to the problem as well. Why? Okay, there. All right, I'm scrolling down. There's a formula exactly for this? Oh. Well, let's look that up. Does the work for you? If you have triangle ABC and you draw, you can set up this exact situation. Wow. Two of which add up to the third. Is it true that if we draw another edge 3 square that fits it around the 1 and 2 squares, it would have a second corner on that circle? Yeah, because these 2 squares add up to like length 3, so you could draw another length 3 square from like here down there to there, and that's where it hits the circle. Back up here, and like it's all. Oh, would it hit again? That'd be hard to judge, I guess. It probably goes past the edge of the circle over there. I don't know. I can't. No, maybe it's inside. I can't tell, to be honest. I don't know if that's even important, though. We might not care about that upper left corner. The radius is not exactly 4.5. Yeah, we could actually calculate it, I guess. It's true. The radius is or it's not exactly 4.5. True. Dude, I don't know. I feel like I can't visualize things right now. Copy over to Paint. Oh, you know, Milk, I think that's just that's the play. I just didn't want to open up GeoGebra, but Paint is always there and it's much easier. Copy. Paint is always there for me whenever I need it most. Okay, so what we do is we're gonna take this and transfer it. I should have drawn it from the lower one in the first place. Ooh, we go just outside. Okay, so that's interesting. We go barely outside the circle there. Draw an imaginary... Oh, if we're going to go with your setup, Milk, yeah, we can look at that. Dude, I know if I zoom out, it's going to zoom way too much out. Yeah. This. Okay, there. Let's say the center is right over yonder. Do you want me to do the setup that you said in chat before? Okay, yeah. Let's make the line. Let's use the line tool here. Let's not get too risque with freehanding stuff. I should really do this in another color, but too late now. Then are we connecting these triangles here? Okay, yeah. So I don't know, is it going to help to like name these points? One more along the box diagonals. Okay. This is like some weird perspective drawing right now. BOC, BOC, and AOB. Sure. We do have isosceles triangles here since these are radii. 3 root 10 over 2. Oh, that is slightly more than 4.5, right? That seems reasonable. Oh. So we know the length of like this diagonal, if we care to calculate it. We know that all these radii are equal length to each other. We know there's an isosceles triangle with ACO, where we know the length of the base. Is that enough information to work out our angles? No. The length of AB, BC, AB, BC, and AC. Oh, I didn't even think about that. So you could always log cosines this thing to get some angles. Okay, yeah, true. So, oh god. AB, you can form a right triangle of long side 6, short side 3. So square root of 3 squared plus 9 squared. Sorry, 3 squared plus 6 squared. 9 plus 36 is 45, which is 3 root 5. That's supposed to be AB, by the way. BC is just 3. AC is root 2 plus 2 root 2, right? Not being stupid? No. 2 root 2. Root 2 plus 2 root 2 plus 2 root 3? No, 3 root 2. Oh, that's kind of neat. Not symmetry, but I guess a pattern. 1 plus 2 plus 3. But I did have to assume that all the things that looked like squares were actually squares, and that all things that looked like straight lines were actually... That's true, but then it could be a sneaky non-Euclidean geometry problem, I guess. So that AOC equals BOC plus AOB, sure. I don't see how we get those angles, though. Because isosceles triangle, we only know the base. The signs of those angles relate to R. I guess if you law of sines it, sure. I'm not connecting the dots, though. Well, to be fair, I did connect the dots from A to C, but I assume we're gonna get some kind of like we're gonna name these angles and just like get a system of equations and have to solve it. Um, hmm. BOC over 3 sine of AOB equals AB over 2R? Where does that come from? It's not a right triangle, necessarily. We know it's isosceles. Oh, you cut it in half. Bisect it. Oh. Why isn't it sine of AOB over 2? Are we dividing the angle in half also? Oh, okay. But yeah, I guess we could certainly make this claim is equal to AB we calculated as 3 root 5. Oops. And we have to divide that by 2. And then we know that AO is R. So I guess you could double angle. I know that's what we want to do. What's Fenlock saying? Can you imagine the diameter circle goes through the corner where the 3 square and the 2 square touch? Oh yeah, the diameter through that point, sure. If you reflect the picture in that diameter, the 3 square has to land right on top of the 1 and 2 squares and nicely fit them in. So you can extend them to get a 4th point on the circle? Oh god. I wasn't completely following that stuff once the reflections started. Oh, I can't resize the canvas without sizing the entire image. Let's just open a new one and paste the image in. Oh god. I want a new window of paint without losing this one. There we go. What? Is that going to scale up the image though? That's what I was afraid of. Let's find out. Oh, it doesn't. Oh my god, Fenbox. Genius. Oh, that's as far as it goes, but that might be enough room. Do I still have it? Okay, cool. Can I just sneak it over here? Okay. This might be unwise to try and sneak it in like this, but let's try it. You actually can't make... Oh, okay, okay. This will serve our purposes at least. So you're saying to draw a diameter, something like that. Oh, okay. And reflect it across the diameter. And you basically have this nice like symmetry. Yeah, I feel like we talked about that a while. Oh no. I think that's what we said before, whether this corner up here will be inside or outside the circle. But maybe we don't care about that, do we? Do a V prime D4 operation on it? A vertical flip. Well, wait, if this is V prime, is that undoing a vertical flip? Oh no, it's when it's prime with the flips. You are gonna have to land exactly on the circle. Really? I don't remember how it works. At 10 bucks, so I'm probably wrong. extend them to get a fourth point on the circle. So wait, it, like, what am I doing with this? Like, I don't even know what I'm vertically flipping, I guess. Like, do I draw these same, oops, do I draw these small ones over and this one up here? You're going to land exactly on the circle because that long, oh my god, my voice. The long chord that bisects all the squares is at right angles to the diameter. Because this chord is perpendicular, is your argument. Every chord is perpendicular to diameters, so I buy that. Okay, yeah. Draw a vertical bisector of the top square and a horizontal bisector of the left one. Vertical bisector of the top square, I assume all the way through? Like, draw the diameter that's a vertical bisector? Yeah, I can't actually pass where I'm scrolled. Oh wait, the left square is in the big left square. We're using symmetry. Oh. I'm still trying to figure out how we find this intersection, I guess. It sounds like that's where you're going with this fem box. Or that's where you're about to touch on next. The radius is the square root of 3/2 squared plus 9/2 squared. Oh, are we working out the right triangle? Oh, no, stop. Deselect that. Are we working out like this right triangle? I feel like it might be possible. Oh wait, no, that doesn't help. Never mind. So we don't know what portion is left above or to the side. Three over 2 squared plus 9/2. Where's the length 9? That's being divided in half. Use the squares to find the coordinates of the 4 points on the circle. Well, if the center is at 0, 0, we don't know where the center is, right? So where are the squares relative to the center? I don't know how we do that if we're like how we fix the center circle at origin when we don't know where the center is. Things look like straight lines and we're actually straight. That's fair. I guess once you get to this stage with the diameters, well, I still don't know how you actually get the distances though. Like, how do we know the distance from the center up to the big square? Top right is 1.5, 4.5. Oh, wait. Oh, I get it. Because I was forgetting about this big square here that we drew. Okay, that's fair. You take half of this big square plus the entire big square to get 4.5 for your y coordinate there. Okay, I'm on board with that then. Or I'm on board with the coordinate system. And so I believe then we can get the coordinates of the other 3 points. How does that help us find the radius? We only need the one? Oh, so you calculate the distance. Oh, I get it. It's just the distance formula. Okay. That makes sense. Jeez. Oops, sorry, I touched the mic, but that didn't make a weird noise. It's a crazy one. Okay, yeah, that's a nice one, Penbox. Oops, I gave you 2 saves, but I meant to give the other one to Milk and Horn, but you deserve two saves, Penbox. How about that? Oh, when was this? Someone posted a question to my Discord. I didn't see it until now, though. Subin in my Discord, are you still around? If you're not around, I'm just gonna get back to you offline. Something about wrapping things up. Oh, you are here? Okay. Let's see if we can figure this out now then, before I wrap up. So you have... a function, you want to find the mass, the moment about the x and y axis, and the centroid of lambda. I haven't done these in a long time. Let me see if I can remember these formulas. I think Paul's Notes has a section on it. I don't remember. Oh, okay, so mass is just density times the integral of the function. Okay, that we can do. The moment about the x-axis. Oh, interesting. Okay, so we can just plug these into their formulas. The center mass is going to be a little bit annoying, but yeah, we can set these up. Let me erase the whiteboard. And I think this will be my last problem for the day. Okay. Jaden 8008S, hey, welcome in. All right, so the mass we said is density times area, and the area is just the integral. We should draw a quick little graph of this though, because we need to figure out what we're going to be integrating over. 4x minus x squared, comma y equals 0. So let's figure out the roots of this parabola just so we can graph it. Thanks for the follow, Subin. We have y equals x times 4 minus x from there. So let's graph this parabola. I'm not going to make it too exact. I just want a general idea of how this thing looks. So we have 1, 0 at x equals 0, another 0 at x equals 4, and we're concerned with the area between the parabola and the x-axis. And there. So there's a nice shortcut for finding the area of a parabolic segment like this. It's 2/3 the area. Oh, that's a Simpsons rule thing, right, Fenbox? We'll do the actual integral, but that is a nice little thing. (32/3). All right, let's see if we get the same thing. All right, so we need to find the mass of this region with density 3 grams per centimeter cubed. I should actually write our density. Rho equals 3g per cubic centimeter. Okay, so mass is... Okay, I just want to make sure I'm finding the right thing. Okay, so mass is density 3 times the integral from 0 to 4, which is important to find the zeros, of our function, 4x minus x squared dx. Integrating this, we get power rule 2x squared minus 1/3 x cubed, evaluated from 0 to 4. So we get 3, plug in 4 there. 4 squared is 16. 16 times 2 is 32. 4 cubed is 64, so we get 64/3. Minus, actually when you plug in 0, you get zeros for all that stuff, okay? Let's multiply the 3 inside to get rid of that fraction. 32 times 3, aren't I getting a way bigger number than I should? No, we'll be okay. 32 times 3 is 96, minus 64. I get exactly 32. That's wrong. That's not what you got, Fembox, so right? Oh, that's the area, and the mass is... Okay, yeah. Okay, we're good. So the mass is 32. We should use our units of grams. I'd say that's the answer for the first part, Subin. 32 is the answer? Okay, cool. Now we need the moment about the x-axis, which I need to look at the formula for. M sub x is density. I'm just going to write the variables, alpha to beta. We only have one function here, so we're going to write f of x squared. dx. All right, plug in, we have everything we need here. So density is 3. Our bounds are 0 to 4. The function is that 4x minus x squared dx. I don't see a trick here, so we're going to have to multiply out the squared, unfortunately. We can do that, though. Let me just make sure I'm not missing anything. Okay, good. So 3 times the integral 0 to 4. No parentheses. Multiplying out this squared, we get 16x squared minus 8x cubed plus x to the 4th dx. Now we can integrate that. 16 over 3x cubed minus 2x to the 4th plus 1/5 x to the 5th from 0 to 4. Okay, we're gonna get, I hope you know your powers of 4. I guess we can convert them to powers of 2 as well, but. All right, so we have 16, which is 4 squared, times 4 cubed is like 4 to the 5th. 4 to the 5th is like 2 to the 10th, which I happen to know is 1024. That's like 2 to the 9th, which is going to be 512. That we said is 1024. And when you plug in 0, you get zeros for all that, so who cares? I'm going to multiply the 3 inside here to get rid of that 3 in the fraction. Three times 512. 1536. Oh god, getting a common denominator here is going to suck. 3,000. $48 plus 24. 72 over 5. This is work for a calculator. I'm going to let Wolfram Alpha get a common denominator for me. 1024 minus 1536 plus 3072 over 5. 512 over 5. I don't know what the moment is measured in. Can I figure it out easily? That's area squared. Which you're integrating in terms of length. So we get a dimension cubed times. Is it just grams? I don't actually know what the grams times seem. That makes sense. 10 blocks. Okay, yeah. Hopefully I see you're typing, so I'll wait to hear back from you. Or I can plug in the initial number to make sure I didn't make a stupid mistake here. To Wolfram. So I was trying to be fancy with knowing my powers of 2. We do get 512 over 5 from Wolfram. Okay, so this should be the right answer unless I set it up wrong. I don't think I did, though. Okay, so next the moment about the y, which is x times f of x. Okay. I'm going to do it over here, I guess. The one in terms of y is density 3. Integral from 0 to 4. Instead of f of x squared, we have x times f of x. So x times 4x minus x squared dx. 4x squared minus x cubed dx. Integrate this, we get 4/3 x cubed minus 1/4 x to the 4th from 0 to 4, which equals 3. 4 to the 4th is like 2 to the 8th is 256 over 3. 4 to the 4th is like 2 to the 8th, which I just did, didn't I? Oh yeah, okay, 286 over 4. Which is more work for a calculator. I typed it in wrong. What? Wolfram, why are you disobeying me? The answer is 64? And Fembox agrees? All right. It's 64 grams times centimeters. All right. Now we have to get the center of mass. So, oh wait, okay, the center of mass is easy. I missed the part of the formula that makes this. We can do the center of mass, the x-coordinate of the center of mass is m sub y over m, which we already have those two pieces, so let's ignore this terrible integral stuff over here. Similarly, the y-coordinate is m sub x over m. Let's just plug that in, and then I think we're done with the problem. X is m sub y, we said is 64, over m, which we said is 32 grams. So we get 2 centimeters. That makes sense. Centimeters make sense for a one-dimensional space. Let's do the same thing for y. We do m sub x, 512 over 5. Over the same thing, 32 grams. 512 is 2 to the 9th. 32 is 2 to the 5th. So we get 2 to the 4th is 16 over 5. Dude, I feel like I'm on point with my powers of 2. Assuming I'm right. Let's verify that last bit of math. It's an axis. Oh, that's a good point, Fedbox. Yeah, it's a parabola. Of course, the center of mass is going to be the x-coordinate is going to be 2 halfway between our two zeros. 512 over 5 over 32. 16 over 5. Heck yeah. No worries, Subin. Hope that makes sense. Let me know if you have any questions. Otherwise, I'm probably going to get out of here. And since you are new around here, if you're interested in other math streamers, there's a whole list of them there that I can recommend the highest. There are more than just that, but if you're ever not around and you need help. Doesn't that y seem high? 16 over 5. When the parabola at x equals 2, the parabola is 8 minus 4 is 4. 16 over 5 is slightly less than 4. That is a little high, I guess. You're right. Did I make an oopsie? M sub x over m. Five over 5 is the correct result for the integral. Oh, there's a 1/2. Subin, I messed up slightly. I missed the 1/2 that's inside the formula for m sub x. That's a good catch, Penbox. And if I don't hear back from you in chat, I'll write back to you in Discord to make sure that you see it. But there's a 1/2 in the formula I dropped off. And that threw off the answer. I don't know why Pulse Notes has the 1/2 inside the integral. Why not have it outside? We can put it outside though. So it's actually going to be 3 over 2 over 2. Let me just manually update this last line. That's 32 times 3, so it is 96. 96 divided by 2. That's the mass? What? The bookends. Oh my god. It's the end of the day. I was editing the wrong equation. I meant to update the m sub x. I didn't actually look at which equation I was updating. Oh my god. It's it's been a long stream, okay? Ugh, okay. 32. The 1/2 goes here. Over 2, over 2, over 2, over 2. Let's just plug that into Wolfram. Do not trust my brain. Oh wait, it's going to be 512 divided by 2. Why did I erase all that? 512 over 2 is 256 over 5. So that was g times cm. And all that's really going to happen is that becomes 250. It's going to be 8 over 5 instead. I think. Let's verify. Eight over 5 is probably more reasonable for our y coordinate. And mx, the answer is 265 or 256 over 5. Okay, cool. Show up on the math streamers over 5 hours in? Yeah, Fembox. You're farming. Okay, so good. The answer for mx matches what you have then. And then let's verify that 256 over 5 over 32 is 8 over 5. Okay, that's a more reasonable answer. So that's what, 1.6? Yeah, okay. So I think that's good then. All right, so hopefully everything else matches Subin. Awesome. Well, thanks so much for the question. If you post something in my Discord and I don't acknowledge it immediately, please feel free to like type in chat that you posted something. 'Cause it's harder for me to look at my Discord while I stream. I do have it open, but I don't always see it immediately. Yeah, I haven't done a problem like that in a while, so it's always nice to get caught up on that. Okay, I'm gonna wrap things up there for the day. The thing is, we now have to choose between two friends again. Because both Zach and Dan are live here, so I raided Zach on Tuesday, right? So maybe we'll raid Dan this time. But let's give a shout out to Zach as well, because if anyone is around here doesn't already know Zach, they should. And we'll raid out to Dan. Oh, goodbye YouTube. I forgot to turn off the stream there.